ಎಲ್ಲರಿಗೂ ಶುಭ ದಿನ. ಹುಲ್ಲಾಗು ಬೆಟ್ಟದಡಿ ಮನೆಗೆ ಮಲ್ಲಿಗೆ ಆಗು, ಕಲ್ಲಾಗು ಕಷ್ಟಗಳ ಬೀದಿ ಮಳೆ ಸುರಿಯೇ, ಕಲ್ಲು ಸಕ್ಕರೆಯಾಗು ದೀನ ದುರ್ಬಲರಿಗೆ, ಎಲ್ಲರೊಳಗೊಂದಾಗು ಮಂಕುತಿಮ್ಮ. ಸಂತ ಜೋಸೆಫರ ಶಿಕ್ಷಣ ಮಹಾವಿದ್ಯಾಲಯವು MDESನ ಸಹಯೋಗದೊಂದಿಗೆ ಆಯೋಜಿಸಿರುವ 6 ದಿನಗಳ ಶಿಕ್ಷಕರ ಸಾಮರ್ಥ್ಯಾಭಿವೃದ್ಧಿ ವೆಬಿನಾರ್ಗೆ 2ನೇ ದಿನಕ್ಕೆ ತಮಗೆಲ್ಲರಿಗೂ ಆತ್ಮೀಯ ಸ್ವಾಗತ. ಸಂತ ಜೋಸೆಫರ ಶಿಕ್ಷಣ ಮಹಾವಿದ್ಯಾಲಯವು ಸುವರ್ಣ ಮಹೋತ್ಸವದ ಸಂಭ್ರಮದಲ್ಲಿ ಮೈಸೂರು ಧರ್ಮಕ್ಷೇತ್ರದ ಶೈಕ್ಷಣಿಕ ಮಂಡಳಿಯ ಇತಿಹಾಸದಲ್ಲೇ ಪ್ರಪ್ರಥಮ ಬಾರಿಗೆ ಈ ಒಂದು ತರಬೇತಿ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ನಾವೆಲ್ಲ ಒಟ್ಟಿಗೆ ಸೇರುತ್ತಿರುವುದು ಮತ್ತು ವೆಬಿನಾರ್ನಲ್ಲಿ ಭಾಗವಹಿಸುತ್ತಿರುವ ಎಲ್ಲಾ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳು ಸಂತ ಜೋಸೆಫರ ಶಿಕ್ಷಣ ಮಹಾವಿದ್ಯಾಲಯದ ಪ್ರಾಧ್ಯಾಪಕರಾಗಿರುವುದು ಕಾರ್ಯಕ್ರಮದ ವಿಶೇಷವಾಗಿದೆ. ಕಲಿಕೆ ಗರ್ಭದಿಂದ ಗೋರಿಯ ತನಕ ನಿರಂತರ ಪ್ರಕ್ರಿಯೆ. ಶಿಕ್ಷಕ ನಿರಂತರ ಕಲಿಕಾರ್ಥಿಯಾಗಿದ್ದಾಗ ಮಾತ್ರ ಬೋಧನಾ ಕಲಿಕಾ ಪ್ರಕ್ರಿಯೆ ಪರಿಣಾಮಕಾರಿಯಾಗಲು ಸಾಧ್ಯ. ಈ ನಿಟ್ಟಿನಲ್ಲಿ ನಿಮ್ಮ ಕ್ರಿಯಾಶೀಲ ಭಾಗವಹಿಸುವಿಕೆ ಮತ್ತು ನಿಮ್ಮ ಅಮೂಲ್ಯ ಈ ಮಾಹಿತಿ ನಮಗೆ ಅತಿ ಅವಶ್ಯಕ. ಕಾರ್ಯಕ್ರಮದ ಕೊನೆಯಲ್ಲಿ ನಾವು ಕಳುಹಿಸುವ ಫೀಡ್ಬ್ಯಾಕ್ ಫಾರ್ಮ್ನಲ್ಲಿ ನಿಮ್ಮ ಇಮೇಲ್ ಐಡಿಯನ್ನ ತಪ್ಪಾಗದಂತೆ ಟೈಪ್ ಮಾಡಿ ಮತ್ತೊಮ್ಮೆ ಪರೀಕ್ಷಿಸಿ ನಂತರ ಸಬ್ಮಿಟ್ ಮಾಡಿ. ಇಂದಿನ ದಿನದ ವಿಷಯ ವಿಜ್ಞಾನ ಮತ್ತು ಗಣಿತ ಬೋಧನೆಯಲ್ಲಿ ನಾವೀನ್ಯಯುತ ಅಭ್ಯಾಸಗಳು. ಪ್ರಸ್ತುತಪಡಿಸಲಿದ್ದಾರೆ ನಮ್ಮ ಕಾಲೇಜಿನ ಸಹಾಯಕ ಪ್ರಾಧ್ಯಾಪಕರಾದ ಶ್ರೀಮತಿ ಶಾಲೋಮ್ ಸನುತಾರವರು. ಕಾರ್ಯಕ್ರಮವನ್ನ ಮುಂದುವರಿಸಬೇಕೆಂದು ಪ್ರಶಿಕ್ಷಣಾರ್ಥಿಯಾದ ಕುಮಾರಿ ಪೂಜಾ KR ರವರನ್ನ ಆಹ್ವಾನಿಸುತ್ತೇನೆ. ಶುಭ ದಿನ. ಧನ್ಯವಾದಗಳು.
ಧನ್ಯವಾದಗಳು ಮ್ಯಾಮ್. ಎಲ್ಲರಿಗೂ ಬೆಳಗಿನ ಶುಭೋದಯಗಳು. ಜಗತ್ತಿನ ಹಲವಾರು ಆವಿಷ್ಕಾರಗಳ ಮೂಲ ನವೀನ ಚಿಂತನೆಗಳು. ಪ್ರತಿಯೊಂದರಲ್ಲೂ ನವೀನತೆಯನ್ನು ಹುಡುಕುವುದು ಮಾನವನ ಸಹಜ ಗುಣ. ಇಂತಹ ನವೀನ ಚಿಂತನೆಗಳು, ನವೀನ ಬೋಧನಾ ಶೈಲಿ ಶಿಕ್ಷಣ ಕ್ಷೇತ್ರದಲ್ಲೂ ಸಹ ಕಾಣಸಿಗುತ್ತವೆ. ಇಂದು ವಿಜ್ಞಾನ ಮತ್ತು ಗಣಿತಶಾಸ್ತ್ರದ ನವೀನ ಬೋಧನಾ ಶೈಲಿಗಳ ಕುರಿತು ಚರ್ಚಿಸಲು ನಾವೆಲ್ಲ ಇಲ್ಲಿ ನೆರೆದಿದ್ದೇವೆ. ಕಾರ್ಯಕ್ರಮವನ್ನು ಪ್ರಾರಂಭಿಸುವ ಮೊದಲು ಯಾವುದೇ ಕಾರ್ಯಕ್ರಮವನ್ನು ಆರಂಭಿಸಲು ದೇವರನ್ನು ಸ್ಮರಿಸುವುದು ರೂಢಿ. ಅಂತೆಯೇ ಇಂದು ಪ್ರಾರ್ಥನಾ ಗೀತೆಯನ್ನು ನೆರವೇರಿಸಿಕೊಡಬೇಕೆಂದು ಸಹೋದರಿ ರೀನಾ ಮತ್ತು ತಂಡದವರನ್ನು
ತಂದೆಯಾದ ದೇವರೇ, ಈ ದಿನವನ್ನು ದಯಪಾಲಿಸಿದ್ದಕ್ಕಾಗಿ ನಿಮಗೆ ವಂದನೆಗಳು. ಈ ವರ್ಚುವಲ್ ವೇದಿಕೆಯಲ್ಲಿ ನಮ್ಮೆಲ್ಲರನ್ನು ಒಂದುಗೂಡಿಸಿದ್ದಕ್ಕಾಗಿ ನಮ್ಮ ಮನದಾಳದ ಕೃತಜ್ಞತೆಗಳು. ನಮ್ಮೆಲ್ಲರನ್ನು ಹರಸಿ ಆಶೀರ್ವದಿಸಿರಿ. ಈ ದಿನದ ಕಾರ್ಯಕ್ರಮವು ಸುಸೂತ್ರವಾಗಿ ನೆರವೇರಲು ನಿಮ್ಮ ವರಪ್ರಸಾದವನ್ನು ದಯಪಾಲಿಸಿರಿ ತಂದೆಯೇ.
ಎದೆಯಾಳದ ಮಾತಿಲ್ಲದ ನನ್ನ ಮೌನ ಹಾಡ ಕೇಳವ, ಎದೆ ಕಂಪನ ಮಿಡಿದು ನುಡಿಯುವ ನನ್ನ ಮೌನ ಹಾಡ ಕೇಳವ, ಹೃದಯದ ಕಲರವಕ್ಕೆ ಜಗವೆಲ್ಲ ಕುರುಡಾಗಿದೆ, ಹೃದಯದ ಕಲರವಕ್ಕೆ ಜಗವೆಲ್ಲ ಕುರುಡಾಗಿದೆ. ನನ್ನ ದೇವನೇ, ನನ್ನ ಇನಿಯನೇ, ನನ್ನ ಮೌನ ಹಾಡ ಕೇಳವ.
ಪ್ರಾರ್ಥನಾ ಗೀತೆಯನ್ನು ಹಾಡಿದಂತಹ ಸಹೋದರಿ ರೀನಾ ಮತ್ತು ತಂಡದವರಿಗೆ ಧನ್ಯವಾದಗಳು. ಮೊದಲಿಗೆ ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ನಮ್ಮೊಂದಿಗಿರುವಂತಹ MDESನ ಕಾರ್ಯದರ್ಶಿಯಾದಂತಹ ಪೂಜ್ಯ ವಂದನೀಯ ಗುರುಗಳಾದ ರೆವರೆಂಡ್ ಫಾದರ್ ವಿಜಯ್ ಕುಮಾರ್ ರವರಿಗೆ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹೃತ್ಪೂರ್ವಕ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇವೆ. ಪ್ರಾರ್ಥನಾ ಗೀತೆಯನ್ನು ನೆರವೇರಿಸಿದ ಸಹೋದರಿ ರೀನಾ ಮತ್ತು ತಂಡದವರಿಗೆ ಧನ್ಯವಾದಗಳು. ಮೊದಲಿಗೆ ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ನಮ್ಮೊಂದಿಗಿರುವ MDSನ ಕಾರ್ಯದರ್ಶಿಯಾದಂತಹ ಪೂಜ್ಯ ವಂದನೀಯ ಗುರುಗಳಾದ ರೆವರೆಂಡ್ ಫಾದರ್ ವಿಜಯ್ ಕುಮಾರ್ ರವರಿಗೆ ಹೃತ್ಪೂರ್ವಕ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. MDSನ ಆಡಳಿತಾಧಿಕಾರಿಯಾದಂತಹ ಪೂಜ್ಯ ವಂದನೀಯ ಗುರುಗಳಾದ ರೆವರೆಂಡ್ ಫಾದರ್ ಅವಿನಾಶ್ ರವರಿಗೂ ಕೂಡ ಇಂದಿನ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹೃದಯಪೂರ್ವಕ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. MDSನ ತರಬೇತಿ ಮತ್ತು ಅಭಿವೃದ್ಧಿಯ ಕಾರ್ಯನಿರ್ವಾಹಕ ಅಧಿಕಾರಿಯಾದಂತಹ ಶ್ರೀಯುತ ಸೆಬಿ ಮವೇಲಿ ಸರ್ ಅವರಿಗೂ ಕೂಡ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹೃದಯಪೂರ್ವಕ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. ಸಂತ ಜೋಸೆಫ ಶಿಕ್ಷಣ ಮಹಾವಿದ್ಯಾಲಯದ ಪ್ರಾಂಶುಪಾಲರಾದಂತಹ ಶ್ರೀಮತಿ ಡಾಕ್ಟರ್ ಪ್ರಿಯಾ ಮ್ಯಾಥ್ಯೂ ಮೇಡಮ್ ರವರಿಗೂ ಕೂಡ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಇಂದಿನ ಕಾರ್ಯಕ್ರಮದ ವಿಷಯವನ್ನು ಕುರಿತು ನಮ್ಮೆಲ್ಲರೊಂದಿಗೂ ಚರ್ಚಿಸಲು ನೆರೆದಿರುವಂತಹ ನಮ್ಮ ಕಾಲೇಜಿನ ಭೌತಶಾಸ್ತ್ರ ಉಪನ್ಯಾಸಕರು ಮತ್ತು ಇಂದಿನ ಕಾರ್ಯಕ್ರಮದ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳಾದ ಶ್ರೀಮತಿ ಶಾಲೋಮ್ ಸನ್ನುತಾ ಮೇಡಮ್ ರವರಿಗೂ ಕೂಡ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹೃದಯಪೂರ್ವಕ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಕೊನೆಯದಾಗಿ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಭಾಗವಹಿಸಿರುವಂತಹ ಎಲ್ಲ ಶಿಕ್ಷಕರಿಗೂ ಹಾಗೂ ಪ್ರಶಿಕ್ಷಣಾರ್ಥಿಗಳಿಗೂ ಕೂಡ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತವನ್ನು ಕೋರುತ್ತೇನೆ. ಇದೀಗ ನಮ್ಮ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳಾದ ಶಾಲೋಮ್ ಸನ್ನುತಾ ಮೇಡಮ್ ರವರನ್ನು ತಮ್ಮಲ್ಲಿರುವ ವಿಜ್ಞಾನ ಹಾಗೂ ಗಣಿತಶಾಸ್ತ್ರದ ವಿಷಯದ ವಿಚಾರಧಾರೆಯನ್ನು ನಮ್ಮೆಲ್ಲರೊಂದಿಗೂ ಹಂಚಿಕೊಳ್ಳಲು ವಿನಂತಿಸಿಕೊಳ್ಳುತ್ತೇನೆ.
Thank you, Pooja. Am I audible? Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
I think I can start. This is a request for the participants. The participants, if they are science teachers, please stay in Google Meet. Others, they can watch us live on YouTube. I think you can, there is live streaming on YouTube of the same presentation, so you can watch there. You can exit Google Meet and you can be with us. All the science teachers can be with us in the Google Meet platform. Others can watch us on YouTube live. Okay, thank you. Let me share the PPT I have. Good morning, everyone. Once again, today we are going to discuss something on teaching science and maths, teaching science and mathematics with some innovative practices. How do you implement innovative practices in your classroom? Innovative practices ಅಂದ ತಕ್ಷಣ ಹೊಸ ಹೊಸ ಐಡಿಯಾಗಳು ಬರ್ತವೆ ನಮಗೆ. ಅದನ್ನ ನಾವು ಹೇಗೆ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ನಿರ್ವಹಣೆ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ನಾವು ಸ್ವಲ್ಪ ಚರ್ಚೆ ಮಾಡೋಣ. ಮತ್ತೆ ನಿಮ್ಗೆ ಏನಿದ್ರು ಪ್ರಶ್ನೆ ಇತ್ತು ಅಂದ್ರೆ ಹ್ಯಾಂಡ್ ರೈಸ್ ಆಪ್ಷನ್ ಇದೆ, ಅದರಲ್ಲಿ ನೀವು ಹ್ಯಾಂಡ್ ರೈಸ್ ಆಪ್ಷನ್ ಮಾಡಿ ನನ್ನನ್ನು ಕೇಳಬಹುದು. I will stop for a while and I'll see that I'll answer your questions. So let us move. Okay, innovative practice ಅಥವಾ innovation ಅಂತ ಹೇಳುವಾಗ ನಾವೀನ್ಯತೆ ಬಗ್ಗೆ ನಾವು ಮಾತಾಡ್ತೀವಿ. ಹೊಸ ಪ್ರಯೋಗಗಳು ಅಂದ್ರೆ ಏನು ಅಥವಾ ಹೊಸ ಪ್ರಯತ್ನಗಳು ನಾವು ಕ್ಲಾಸ್ ರೂಮ್ ನಲ್ಲಿ ಶಾಲಾ ಕೊಠಡಿಯಲ್ಲಿ ಹೊಸ ಪ್ರಯತ್ನಗಳು ಅಂದ್ರೆ ನಾವು ಏನ್ ಮಾಡ್ಬೋದು ಅನ್ನುವಂಥ ವಿಷಯಗಳನ್ನ ನಾವು ಮಾತಾಡ್ತೀವಿ. ಇನ್ನೋವೇಟಿವ್ ಪ್ರಾಕ್ಟೀಸಸ್ ಅಂತ ಹೇಳುವಾಗ ವಾಟ್ ಐ ಫೆಲ್ಟ್, ನನಗೆ ಅನಿಸಿದ್ದು 3 ವಿಷಯ: ಎಸ್ಟಿಮೇಷನ್, ವಿಜುವಲೈಸೇಷನ್ ಆ್ಯಂಡ್ ಇನ್ಫ್ಯೂಷನ್. ಎಸ್ಟಿಮೇಷನ್ ಅಂತ ಹೇಳುವಾಗ ಮಕ್ಕಳಿಗೆ ನಾವು ಏನೇ ಒಂದು ವಿಷಯದ ಬಗ್ಗೆ ಮಾತಾಡುವಾಗ ಅಥವಾ ಅವ್ರಿಗೆ ಏನಾದ್ರು ಹೇಳುವಾಗ ಅಂದಾಜು ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳ್ಕೊಡ್ಬೇಕಾಗುತ್ತೆ. ಇದು ಇತ್ತೀಚಿನ ದಿನಗಳಲ್ಲಿ ಎಷ್ಟೋ ಜನ ಮಕ್ಕಳಲ್ಲಿ ನಾವು ನೋಡೋದಿಲ್ಲ, ಗಮನಿಸೋದಿಲ್ಲ. ನಾವು ಎಸ್ಟಿಮೇಷನ್ ಹೇಳುವಾಗ ಅಂದಾಜು ಮಾಡುವಿಕೆ. ವಿಜುವಲೈಸೇಷನ್, ಹೇಗೆ ಅದನ್ನ ಚಿತ್ರಿಸ್ಕೋತಾರೆ ಅವ್ರ ಮನಸ್ಸಿನಲ್ಲಿ ಆಗಿರ್ಬೋದು, ಅಥವಾ ಅವ್ರು ಕೇಳುವಾಗ ಅವರ ಕಣ್ಣು ಮುಂದೆ ಏನ್ ಚಿತ್ರಗಳು ಬರ್ತವೆ ನಾವೊಂದು ವಿಷಯ ಹೇಳುವಾಗ. ಈಗ ಒಂದು ವಸ್ತು, ಬಾಡಿ ಇಸ್ ಮೂವಿಂಗ್ in a speed of 3 km/h. If I say that, how will you visualize things? So that is very important to have innovative practices. And next is infusion. How will you relate 2-3 items together, 2-3 subjects together, 2-3 concepts together, and then bring up innovative practices? ಹೊಸತನ ತರಬೇಕು ಅಂತ ಹೇಳಿದಾಗ ಯಾವ ವಿಷಯಗಳ ಸಂಯೋಜನೆ ಆಗಬೇಕು, ಯಾವ ವಿಷಯಗಳು ಒಂದಕ್ಕೊಂದು ಹೊಂದ್ಕೊಳ್ತಾ ಹೋದಾಗ ನಮ್ಗೆ ಹೊಸ ನವೀನ ಪ್ರಯೋಗಗಳಿಗೆ ನಾವು ಎಡೆ ಮಾಡ್ಕೊಳ್ತೀವಿ ಅನ್ನೋ ವಿಷಯ ತುಂಬಾ ಮುಖ್ಯ ಆಗುತ್ತೆ ಅಂತ ಅನಿಸುತ್ತೆ. ಸೊ 3 important factors in innovative practices is estimation, visualization and infusion. So going to the next practice, next slide. Okay, there's one small example which I would like to show you on this slide. So we all know certain things about solar system and we learn it very early. 7ನೇ ಕ್ಲಾಸ್ನಲ್ಲೇ ಮಕ್ಕಳಿಗೆ ಬಹುಶಃ ಸೋಲಾರ್ ಸಿಸ್ಟಮ್ ಅಂದ್ರೆ ಏನು, ಸೌರವ್ಯೂಹ ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ಅಂತ, ಸೋಲಾರ್ ಸಿಸ್ಟಮ್ ಬಗ್ಗೆ ಸುಮಾರು ಜನಕ್ಕೆ ಗೊತ್ತಿರುತ್ತೆ, ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿರ್ತೀವಿ. ಅದರಲ್ಲಿ ಸಮಸ್ಯೆ, ಮಕ್ಕಳಿಗೆ ಏನೇನು ಸಮಸ್ಯೆ ಕಾಡಬಹುದು ಅಂತ, ವಾಟ್ ಇಸ್ ದ ಪ್ರಾಬ್ಲಮ್ ಇನ್ ಆಕ್ಚುಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ದ ಸೋಲಾರ್ ಸಿಸ್ಟಮ್ ಪಾರ್ಟ್ ಇಸ್ ಸಿಂಪಲ್. It is the visualization. We are showing them what is the structure of the solar system, but we are actually not telling them how huge, how enormous it could be. And sometimes we are talking about the orbits, planetary motions and so many things, and we are not telling how it is related to each other. Now when I say sun, I cannot give a comparison of how big it is when I teach about the structure. So ಸೂರ್ಯ ಎಷ್ಟು ದೊಡ್ಡದಿದೆ ಅಂತ ಹೇಳುವಾಗ ಮಾತ್ರ ಮಕ್ಕಳಿಗೆ ಭೂಮಿ ಯಾಕೆ ಗ್ರಹಣ ಆಗುತ್ತೆ ಅಂತನೋ, ಅಥವಾ ಭೂಮಿ ಶ್ಯಾಡೋ ಎಷ್ಟರ ಮಟ್ಟಿಗೆ ಸೂರ್ಯನ ಮೇಲೆ ಬೀಳುತ್ತೆ, ಎಷ್ಟು ದೂರ ಇದ್ರೂ ಅದು ಗ್ರಹಣ ಯಾಕಾಗುತ್ತೆ, ಇಂಥ ವಿಷಯಗಳು ಅರ್ಥ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So we have to talk about the huge size, the size and space of a particular thing in science. So innovation ಆಗಬೇಕು ಅಂದಾಗ ಮಕ್ಕಳಿಗೆ ಎಷ್ಟು ದೊಡ್ಡ ಸೈಜ್ ಸ್ಪೇಸ್ ಬಗ್ಗೆ ನಾವು ಹೇಳ್ತೀವೋ, ಎಷ್ಟು ದೊಡ್ಡ ಇಮ್ಯಾಜಿನೇಷನ್ ನಾವು ಅವರಿಗೆ ಸ್ಕೋಪ್ ಕೊಡ್ತೀವೋ, ಅಷ್ಟು ಚೆನ್ನಾಗಿ ಅವರಿಗೆ ಹೊಸ ಐಡಿಯಾಗಳು ಹೊಳೆಯೋಕೆ ಸಾಧ್ಯ, ಅಥವಾ ಇರೋದನ್ನ ನೀಟಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಸಾಧ್ಯ ಅಂತ ನನಗೆ ಅನ್ಸುತ್ತೆ. ನೆಕ್ಸ್ಟ್, ಸೊ ಒನ್ಸ್ ಅಗೇನ್ ದಿಸ್ ಇಸ್ Shalom Sanada. So I'll be starting with innovative practices today. So you can share something with me if you have any innovative practices on ss@stjcollegeofeducation.mysuru.in. This is our email when you have to contact us. ಏನೇ ಇದ್ರ ಬಗ್ಗೆ ಚರ್ಚೆ ಮಾಡಬೇಕು ಅಂತಿದ್ರು ಅಥವಾ ನನ್ನ ಜೊತೆ ನೀವು ಹಂಚ್ಕೊಳ್ಬೇಕು ಅಂತಿದ್ರು ವಿಷಯವನ್ನ ನೀವು ಈ ಮೇಲ್ಗೆ ನೀವು ಡ್ರಾಪ್ ಮಾಡ್ಬೋದು, ನಿಮ್ಮ ಮೇಲ್ಸ್ ಅಂಡ್ ಮೆಸೇಜ್ನ ಡ್ರಾಪ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಫರ್ದರ್ ಗೋಯಿಂಗ್ ಆನ್ ವಿತ್ ವಾಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್ ಟುಡೇ. ಇವತ್ತು ಏನೇನು ಕಲ್ತ್ಕೊಳ್ತೀವಿ ಅಂತ ಯೋಚನೆ ಮಾಡುವಾಗ ಫಸ್ಟ್ ನಾನು ಹೇಳೋಕೆ ಬಂದಿರುವಂಥ ವಿಷಯ ಡಿಸ್ಕ್ರೈಬಿಂಗ್ ವೇರಿಯಬಲ್ಸ್ ಇನ್ ಸೈನ್ಸ್. ವೇರಿಯಬಲ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಈಗ ಎಕ್ಸ್, ವೈ, ಝೆಡ್, ಆಲ್ಜಿಬ್ರಾ, ಮ್ಯಾಥ್ಸ್ ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ ಮಕ್ಳಿಗೆ ಭಯ ಆಗೋಕೆ ಶುರು ಆಗುತ್ತೆ. P ಫಾರ್ಮ್, ಎಕ್ಸ್ ವೈ ಝೆಡ್, ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್, ವೈ ಸ್ಕ್ವೇರ್ ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ ಮಕ್ಳಿಗೆ ಭಯ ಆಗೋಕೆ ಶುರು ಆಗುತ್ತೆ. ಯಾಕೆ ಹಂಗೆ ಹೆದರ್ಕೊಳ್ಬೇಕಾಗತ್ತೆ, ಅಥವಾ ಯಾಕೆ ಅದು ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಅಂತ ಅನ್ಸುತ್ತೆ ನಮ್ಗೆ? ಇದು ನಾವು ಕಲಿಯುವಾಗ್ಲೇ ಕಷ್ಟನಾ, ಅಥವಾ ನಾವು ಅದನ್ನ ಕಷ್ಟ ಮಾಡ್ಕೊಂಡಿದೀವ, ಅಥವಾ ಅದು ಸುಲಭವಾಗಿ ನಮ್ಗೆ ಹೇಳ್ಕೊಡೋರು ಯಾರು ಇರ್ಲಿಲ್ವಾ? ಈ ತರದ್ದು ಅನೇಕ ವಿಷಯಗಳನ್ನ ನಾವು ಚರ್ಚೆ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ವೆರಿ ಫಸ್ಟ್ ಥಿಂಗ್ ಇಸ್ ಡಿಸ್ಕ್ರೈಬಿಂಗ್ ವೇರಿಯಬಲ್ಸ್ ಇನ್ ಸೈನ್ಸ್ ವಿತ್ ರೆಫರೆನ್ಸ್ ಟು ಆಲ್ಜಿಬ್ರಾ ಅಂಡ್ ಜಾಮೆಟ್ರಿ. ಮ್ಯಾಥ್ಸ್ ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ ಎಷ್ಟೋ ಮಕ್ಳು ಹೆದರ್ಕೋತಾರೆ. ಮ್ಯಾಥ್ಸ್ ಅಂದ್ರೆ ಕಷ್ಟ, ಸೈನ್ಸ್ ಆದ್ರೆ ಓಕೆ. ಸಮ್ಟೈಮ್ಸ್ ಸೈನ್ಸ್ ಅಂಡ್ ಮ್ಯಾಥ್ಸ್ ದೇ ನೆವರ್ ವಾಂಟ್ ಟು take up as their main subject in higher studies. So there are a lot of problems, and we'll just see, is it really a problem, or are we complicating it, or is it really complicated? We'll just find out. Next is formulating something in science and maths. See, once we learn what is this algebra, what is this geometry, what is science, and science is full of maths and maths is full of science, we understand that it is nowhere two different subjects. ಸೈನ್ಸ್ ಮ್ಯಾಥ್ಸ್ ಬೇರೆ ಬೇರೆ ಅಲ್ವೇ ಅಲ್ಲ. ವಿಜ್ಞಾನ ಮತ್ತು ಗಣಿತ ಅನ್ನುವಂಥದ್ದು ಎರಡೂ ಕಂಬೈನ್ ಆಗಿ ನಾವು ಅದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗಿರುವಂತ ಒಂದು ಸಬ್ಜೆಕ್ಟ್ ಅಂತ ನಮ್ಗೆ ಅನ್ಸ್ತಾ ಹೋಗುತ್ತೆ. ಯಾವಾಗ ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ಫ್ಯೂಷನ್ ಅಂತ ನಾನು ಹೇಳಿದೆ ಮುಂಚೆನೆ, ಬೆರ್ತ್ಕೊಳ್ಬೇಕು. ಬೆರ್ತ್ಕೊಂಡು ನಾವು ಅದನ್ನ ಓದ್ಕೊಳ್ಳುವಾಗ ಇನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಮತ್ತೆ ಅದರಲ್ಲಿ ಒಂದು ಹೊಸತನಕ್ಕೆ ಒಂದು ಪ್ರಾವಿಷನ್ ಇದೆ, ಇನ್ನೋವೇಟಿವ್ ಪ್ರಾಕ್ಟಿಸಸ್ಗೆ ಪ್ರಾವಿಷನ್ ಇದೆ ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. The next is about science and maths and stories. And last thing I want to tell you a little bit about cognitive maps and how it is helpful for your teaching and learning and evaluation, all those things. So we'll go with the very first slide. So describing variables in science. Let me quote this Phil McKinney quotation. He says, innovation is not the result of chance, it's the result of action. It's not the thing to wait for, it's a thing to do. Most of the time, we find that if we have an idea, we tend to tell people that, okay, I'm waiting for an opportunity to tell this, or I'm waiting for a platform to do it. But innovation doesn't come when you wait or when you are seeking for an opportunity. It is when you start doing, and it just happens when you start doing and when you put yourself into action. ಏನಾದ್ರೂ ಕೆಲಸ ಮಾಡ್ತಿರುವಾಗ ಅಥವಾ ಯಾವ್ದಾದ್ರು ಒಂದು ಕ್ರಿಯೆಯಲ್ಲಿ ನಾವು ತೊಡಗಿಸ್ಕೊಂಡಾಗ ಮಾತ್ರನೇ ಹೊಸತನ ಹುಟ್ಟುತ್ತೆ ಅಂತ ಇನ್ನೋವೇಷನ್ ಬಗ್ಗೆ ಅವ್ರು ಡಿಫೈನ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾರೆ. ಅದು ಹೌದು, ಖಂಡಿತ ಅದು ನಿಜ. ಬಹುಶಃ ಈ ಇಡೀ ಪ್ರೆಸೆಂಟೇಷನ್ ಮುಗಿಯೋ ಹೊತ್ತಿನಲ್ಲಿ ನಾವು ಅದನ್ನ ಒಪ್ಕೊಳ್ಬೇಕಾಗತ್ತೋ ಇಲ್ವೋ ಅನ್ನೋಂತ ನೀವು ಹೇಳ್ಬೇಕು ನನಗೆ. ಸೊ ಹ್ಯಾವ್ ಯು ಎವರ್ ವಂಡರ್ಡ್ ವಾಟ್ ವೇರಿಯಬಲ್ಸ್ ಆರ್? ಪ್ರತಿ ಕ್ಲಾಸ್ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಅದು BEd ಅವ್ರಾಗಿರ್ಬಹುದು ಅಥವಾ ಸ್ಕೂಲ್ ಮಕ್ಕಳೇ ಆಗಿರ್ಬೋದು, ಕಾಲೇಜ್ ಅವ್ರಾಗಿರ್ಬೋದು, ಡಿಗ್ರಿ, ಮಾಸ್ಟರ್ ಡಿಗ್ರಿ, wherever we go, in fact, sorry. What happens is when we talk about variables, people tend to feel, okay, it is something about a big derivation or something about a big formula, or which is really complicated, which has too many steps. They have this notion, but you don't have to worry like this. So let us start our innovation practices or our innovative ideas through this very basic thing called variables. So variables, if you want to find out what is this variable, so let us find out some answers initially. So beginning with very simple questions, I would like to tell you a secret. We actually have learned variables in our kindergarten. So UKG, LKG stages allalla na variables odirtive, adana namage gottiralla ashte. So you have to find me, you have to help me find some solutions for this. Now, if you can answer the first question here on the table, if you can do that, that'll be, you can put your answers on the chat box. I'll just find out the chat box. Now you're looking at an exercise sheet, which is of a very basic level, and you can just answer, what is this first thing, the pink color one? What is the answer you'll be writing on the board? ನೀವು ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ನಿಮ್ಮ ಆನ್ಸರ್ನ ಟೈಪ್ ಮಾಡಬಹುದು. I think we've got one. Yes, Abhilash Aradhya, thank you. You have written it as 4. Very nice. This is how we answer the question initially. So we see there are 4 butterflies and we just write 4. And the next answer would be 1. And the next it goes like 3 ducks and so many fishes, 2 apples. It goes on and on and on. Very nice. So we have another slide. I think it is one and the same. Your answer and the key answer given here will match. And therefore it is one and the same. Now, when I say 3 here, it refers to 3 teddy bears, which is there. So obviously we would match like this. Now, when we find out what these things are, they are nothing but some numbers with the variables. Now, when I say butterflies refers to a variable or a unit. I would say butterfly. There are 4 butterflies. Since they are very much alike, very much identical, I would say 4 butterflies. And I would write it as not just 4, but 4B. 4 butterflies, or 1 mushroom as 1M. So here is the first thing where we try to start identifying the variables, quantities, physical quantities. So this is the initial stage where we combine maths and science and we go on. Now, when I ask the same question once again, now you have this pink butterflies here. Now, if you have to number them, how many butterflies are there? Or what is your answer for this? You can type this in chat box, or both the boxes here, both the images. You can type the first one with pink and these colorful things. You can type the answer in the chat box. Okay, Jacinta ma'am says it is 4. Okay, again it is 4 butterflies. And any other answers? Yes, there are so many answers. Very nice. Thank you. Ranjini, Madam Ranjini, Madam Mary Steffi, Geeta Bhima, 4B. Very nice. Somebody is saying, Geeta ma'am, Greta, I'm sorry. Yeah. Ma'am is saying 4B, and she's right. Yes, it is 4B. Excuse me. Okay. So madam is saying 4B. When she says 4B, I would completely agree with that. Yes, it is 4 butterflies. But it is not the same as the previous one. If I check out with the previous one, these 4 butterflies were identical and you would call it 4 units. They are identical. You can't change them. But here, when you say 4 butterflies, all 4 are varying. There are 4, but one is big in size, one is small in size, one is really tiny in size. And when you come to the next image, there are 6 butterflies. We can write it 6B, but here the B is a variable because it has different colors. So variable X, Y, Z, whatever we study is as simple as this one. X can be anything, Y can be anything. Even if it is 6X or 6Y, when I say these butterflies, I'll refer it as 6Y instead of 6B, then all Ys are different in color. They are entirely different in their size, shape, color. So this becomes, the symbol of such things becomes variable, and that is how we define variable in science. In science or maths, a variable is a symbol which works as a placeholder for expression or quantities that may vary or change. It keeps varying or it keeps changing, but it looks like they are similar. So we put it as either X or B or Y or whatever. So why do you have to say this is because we have to learn the basic of locating or formulating or calculating something. So 4B here refers to 4 times the butterfly. So 4B, if B is varying, then it is 4 becomes the coefficient and B becomes a variable. These are very basic things which are very easy, and we usually learn this in our kindergarten, and we don't have to worry you don't have to feel frightened when you look at x squares and y squares and xy cubes and all. It's as simple as these ones. Okay, so now it is time to find out who is this Mr. X. This Mr. X is always troubling science people and maths people from generations. So we'll just sort this out today. So overall, when you look at an expression like this, you call it an algebraic expression where X or a B or Y or Z becomes a variable, and the number which is just right next to it becomes a coefficient. And then 5x plus 7. 7 is a number which we cannot alter at all. So it's 7 quantity, 7 unit, it is just 7. So it becomes a constant which we cannot change, it cannot vary. So this is called a general algebraic expression. Okay. Moving on to further basics, I would just say there are 2-3 variables together. Usually when I look into children solving maths, they would say 2x plus y. Why don't we add 2x plus y and write 3xy? They have such doubts. We have to solve this because we have to tell them that x and y are 2 different things. Though they are varying, they are 2 different things. Now, when I refer to 2x, here 1x refers to 2 butterflies. So, and y refers to 1 ball. So totally there are 5 quantities, and x plus y cannot be added together. There's always a confusion among children that whether is it possible to add this x plus y. No, there are 2 different things and we cannot really add them. And these are some basic things. Now here x refers to 4 butterflies and y refers to 3 balls, and completely it gives us a result of 11 quantities altogether. Now these are some basics which you all know. Why I started with this is to continue with how this beautiful thing called variable and constant and coefficients are related with science, and how beautiful it can be if science gives us formula and it is applicable everywhere. Now, coming to the next level of these butterflies and balls, it's in chemistry. Now we are talking about the atoms and molecules. So it is as simple as that, which we don't have to worry at all. So chemistry is an easy thing now. Chemical equations becomes easy because we are talking about CH4. If you look into the image, it is 1 carbon atom with 4 hydrogen atoms, which is attached. So you know what is the symbol for carbon C, it is H, hydrogen, it is H, and then it is O2 molecule, which has the symbol O. So we have 2 O2 molecules. So this is how you have an equation, and this is nothing but derived from basic maths. And similarly, talking about only variables, when it comes to physics, we all know this famous formula F is equal to m into m, F is equal to m into a, where all 3 are variables. Now, when I say all 3 are variables, looking at what happens in this simple example, there is a boy who is applying some force on this card, and there is movement. So there is acceleration. Once you put some mass into it, it is the same boy who's applying force, but the force is changing. It is not the same when he pushes the empty cart and with that of the cart which when he pushes with the load. So the mass is not varying here, so mass becomes constant. And if the boy is pushing, the force will vary, and according to force, the acceleration will vary. So F is equal to m into a. Now we understand what is this variable. It is just like those colorful butterflies with different colors and different sizes. So according to force, if force varies, your acceleration will also definitely vary. And mass m becomes constant. Now m can be 60 kgs, for example, it can be 500 grams, it can, and F and A becomes variables. Now you can ask me, ma'am, if 4B, when you say 4 butterflies and 4B refers to a variable, when I say 60 kg, will kg also refer to a variable? No, that's why I said my very first example was identical butterflies. 4 identical butterflies where when you say 4B, there B refers to the units because they are identical, they are fixed. Here kg is a value which is fixed. We cannot change that. It is same throughout the world. So that becomes units and it is not a variable. Okay. So, and one more important thing I wanted to tell you, remind you before we get into some basics is when we teach something in physics or in science in general, we have to relate it with directly with maths, and that becomes an infusion idea to make children's recalling power really strong. So for example, we know 3 4s are 12. It's a table, we all know 3 4s are 12. But how many times are we telling this as 3 times 4 or 4 times 3? It is very important to elaborate this multiplication definition like this, because that's how we understand science, in the form of definition and not merely a mathematical expression. So 3 times 4, 4 times 3. ಮೂರನ್ನ 4 ಸತಿ ಹಾಕ್ಬಹುದು ಅಥವಾ 4ನ್ನ 3 ಸತಿ ಹಾಕ್ಬಹುದು. ಆವಾಗ ಅದು ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳುವಾಗ ಮಾಸ್ ರಾಶಿನ ವೇಗೋತ್ಕರ್ಷದ ಅಷ್ಟು ನಾವು ಹಾಕ್ಬೇಕಾಗುತ್ತೆ ಅಂದ್ರೆ m ಟೈಮ್ಸ್ a ಅಂಡ್ a ಟೈಮ್ಸ್ m. ಇಂಥ ಒಂದು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಕೂಡ ಮಕ್ಳಿಗೆ ಬರ್ಬೇಕಾಗತ್ತೆ. ಅಂದ್ರೆ ಮಾಸ್ ಅಂತಂದ್ರೆ ಒಬ್ಬ ವ್ಯಕ್ತಿ ಅಥವಾ ಒಂದು ವಸ್ತು ಅಲ್ಲಿದೆ ಅಂತಂದ್ರೆ ಅದಕ್ಕೊಂದಿಷ್ಟು ರಾಶಿ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಪ್ರತಿಯೊಂದು ಅಣು, ಇಡೀ ಅಲ್ಲಿರುವಂತ ವಸ್ತುವಿನ ಪ್ರತಿಯೊಂದು ಅಣುವಿಗೂ ವೇಗೋತ್ಕರ್ಷ ಇದೆ ಅಂದ್ರೆ ಅದು ಮಲ್ಟಿಪ್ಲೈ ಆಗ್ತಾ ಇದೆ ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡಿಸ್ಕೊಳ್ಬೇಕು. ನೆಕ್ಸ್ಟ್, algebraic equation simply means a statement of equality of two expressions formulated by applying to a set of variables. So here we have an expression which has equality symbol and we have some mathematical operations, plus irbodu, minus irbodu, multiplication irbodu, division irbodu, yavadadru irbodu, addition irbodu. Hinge ಒಂದು mathematical operation ಜೊತೆಗೆ equation, equal symbols ಇರುವಂತ ಒಂದಿಷ್ಟು f is equal to m into a ಅಂತ ಹೇಳುವಾಗ ಒಂದು ವೇರಿಯೇಬಲ್ಸ್ ಇದ್ದಾಗ ಅದನ್ನ ನಾವು algebraic expression ಅಂತ ಕರೀತೀವಿ. So these are some basic examples for you. Just to start with, it's not because I'm not teaching it because we don't know about it. It is just to simplify things and make it reminding you that these are the things which we have learned in our kindergarten classes. So coming to this point, now it has always been a wonderful thing when children observe lightning and thunder. ಗುಡುಗು ಸಿಡ್ಲು ಆದಾಗ ಸುಮಾರು ಮಕ್ಕಳ ಪ್ರಶ್ನೆ ಇದ್ದೇ ಇರುತ್ತೆ. ಅದ್ರ ಬಗ್ಗೆ ಕೇಳ್ತಾರೆ ಅವ್ರು, ಗುಡ್ಗೆ ಯಾಕೆ ಹಿಂಗಾಗುತ್ತೆ, ಸಿಡ್ಲು ಯಾಕೆ ಬರುತ್ತೆ, ಅಥವಾ ಮಿಂಚ್ ಫಸ್ಟ್ ಬಂದ ಆಮೇಲೆ ಯಾಕೆ ಶಬ್ದ ಬರುತ್ತೆ, ಗುಡುಗಾಗುತ್ತೆ ನಮ್ಗೆ, ಇದೆಲ್ಲ ಕೇಳ್ತಾನೆ ಇರ್ತಾರೆ ಅವ್ರು. ಪ್ರಶ್ನೆಗಳಿದು ಸಹಜವಾಗಿ ಎಲ್ಲ ಮಕ್ಳಿಗೆ ಬರುವಂಥದ್ದು. ಇದಕ್ಕೆ ನಾವು ಹೇಗೆ ಉತ್ತರ ಕೊಡ್ತೀವಿ? ಒಬ್ಬ ಸೈನ್ಸ್ ಟೀಚರ್ ಆಗಿ ಅಥವಾ ಒಂದು ಸೈನ್ಸ್ ಸ್ಟೂಡೆಂಟ್ ಆಗಿ ಮಕ್ಕಳು ಅದನ್ನ ಹೇಗೆ ಅರ್ಥ ಮಾಡ್ಕೋತಾರೆ ಅನ್ನುವಂಥದ್ದೇ ನನಗೆ ಇದೊಂದು ಉದಾಹರಣೆ ಅಷ್ಟೇ. ಇದೊಂದು ಅಮೇಸಿಂಗ್ ಥಿಂಗ್. ಸೊ ವಿ ವಿಲ್ ಜಸ್ಟ್ ಫೈಂಡ್ ಔಟ್ ಹೌ ವಿ ಕ್ಯಾನ್ ಗೋ ವಿತ್ ದಿಸ್. ಸೊ ನನಗೆ ಒಂದು ಹುಡುಗ ಪ್ರಶ್ನೆ ಮಾಡಿದಾಗ ನನಗನ್ನಿಸ್ತು, ಬಹುಶಃ ಇದೆಲ್ಲ ನಾವು ಫಿಸಿಕ್ಸ್ನ 8th 9th ಅಲ್ಲೆಲ್ಲ ಸುಮಾರು ಓದ್ಕೊಂಡಿರ್ತೀವಿ. ಸ್ಪೀಡ್ ಬಗ್ಗೆ ಗೊತ್ತಿರುತ್ತೆ, ಸ್ಪೀಡ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡಿಸ್ಟೆನ್ಸ್ ಬೈ ಟೈಮ್, ಇದೆಲ್ಲ ಓದ್ಕೊಂಡಿರ್ತೀವಿ. ಬೇಸಿಕ್ ಫಾರ್ಮುಲಾಸ್, ನಮ್ಗೆ ಎಲ್ರಿಗೂ ಪರಿಚಯ ಇರುವಂತ ಫಾರ್ಮುಲಾಸ್. ಹಿಂಗೆ ಮಾತಾಡುವಾಗ ಒಂದಿನ ಒಂದು ಚಿಕ್ಕ ಹುಡುಗ ಕೇಳ್ತು ನನಗೆ, ಮೊದಲು ಮಿಂಚ್ ಹೊಡೆಯುತ್ತೆ, ಸಿಡ್ಲು ಹೊಡೆಯುತ್ತೆ, ಆಮೇಲೆ ಗುಡುಗು ಶಬ್ದ ಆಗುತ್ತೆ, ಯಾಕೆ? ಸರಿ, ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ಗೊತ್ತು ನಮಗೆ, ಬಿಕಾಸ್ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ಇಸ್ ಟ್ರಾವೆಲ್ಸ್, ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ಇಸ್ ಹೈಯರ್ ದೆನ್ ಸ್ಪೀಡ್ ಆಫ್ ಸೌಂಡ್. ಮೊದಲು ಬೆಳಕು ಬರುತ್ತೆ, ಆಮೇಲೆ ಗುಡುಗು ಶಬ್ದ ಬರುತ್ತೆ. ಅದು ಒಟ್ಟಿಗೆನೆ ಆಗುತ್ತೆ, ಸಂಘರ್ಷ, ಕಾನ್ಫ್ಲಿಕ್ಟ್ಸ್, ಇಟ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಟುಗೆದರ್, ದ ಬಂಬಾರ್ಡ್ಮೆಂಟ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಟುಗೆದರ್, ಬಟ್ the time it takes to reach us is a very long time. So ಇದನ್ನ ಉತ್ತರ ಕೊಟ್ಬಿಟ್ಟೆ ನಾನು. ಅವಾಗ ಆ ಹುಡುಗ ಕೇಳ್ತು, ನೆಕ್ಸ್ಟ್ ಪ್ರಶ್ನೆ ಹುಡುಗ ಕೇಳ್ತು, ಈ ಗುಡುಗು ಇದೆಯಲ್ಲ, ಈ ಗುಡುಗು ಬರ್ತಿದ್ಯಲ್ಲ, ಅದು ಎಲ್ಲಿಂದ ಬರ್ತಿದೆ ಅಂತ ಕೇಳ್ತು. ನಾನಂದೆ ಮೋಡದಿಂದ ಬರ್ತಿದೆ. ಸರಿ, ನಮ್ಮನೆ ಮೇಲ್ಗಡೆ ಮೋಡ ಇಲ್ಲ, ಅದು ಎಲ್ಲೋ ಮೋಡ ಕಾಣಿಸ್ತಿದೆ, ಆದ್ರೆ ಶಬ್ದ ಮಾತ್ರ ಬರ್ತಿದೆ ನಮ್ಗೆ, ನಮ್ಮನೆ ಮೇಲಂತೂ ಇಲ್ಲ. ಅದು ಎಷ್ಟು ದೂರದಿಂದ ಬರ್ತಿದೆ, ಯಾವ ಊರಿಂದ ಬರ್ತಿದೆ ಅಂತ ಕೇಳ್ದ. So then I had to realize, okay, we have to find out the distance from where this thunder is happening. So if we have to do that, what is the idea behind this? What is the physics behind this? Then it was very simple, which I got to learn from another small boy from a school. He taught me it is very simple. Once you have the lightning, let me go to the next slide and tell you. So lightning strikes, ಮಿಂಚ್ ಬಂದ ತಕ್ಷಣ ಒಂದೊಂದ್ಲ ಒಂದು, ಒಂದೆರಡ್ಲ ಎರಡು, ಒಂದೆರಡ್ಲ ಮೂರು, ಒಂದೆರಡ್ಲ ನಾಲ್ಕು ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ ಗುಡುಗು ಬರುತ್ತೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಈಗ ಎಷ್ಟಾಯ್ತು? 4 ಆಯ್ತು. ಸೊ ಟೈಮ್ ಹಿಯರ್ ಇಸ್ 4 seconds. So let me repeat. Whenever there's a lightning which is striking, we would just say 1 1s are 1, 1 2s are 2, 1 3s are 3, 1 4s are 4. So there is 4 seconds. Now time becomes 4 seconds. Now we know what is the speed of light. It is 3 into 10 power 8 meter per second. So we will start counting till the thunder comes. ಮಿಂಚ್ ಹೊಡೆದು ಗುಡುಗು ಬರೋ ತನಕ ಕೌಂಟ್ ಮಾಡ್ತೀವಿ. ಸೆಕೆಂಡ್ಸ್ ಎಷ್ಟು ಸೆಕೆಂಡ್ಸ್ ಅಂತ ನಮಗೆ ಗೊತ್ತಾಗೋಗುತ್ತೆ. ಆಮೇಲೆ ಫಾರ್ಮುಲಾ ಗೊತ್ತೇ ಇದೆ ನಮಗೆ, ಸ್ಪೀಡ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡಿಸ್ಟೆನ್ಸ್ ಬೈ ಟೈಮ್. ಇಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದ್ರಿಂದ ಅದನ್ನ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಸ್ಪೀಡ್ ಇಂಟು ಟೈಮ್ ಮಾಡ್ತೀವಿ. ಸೊ 3 into 10 power 8 meter per second ಇಂಟು ಎಷ್ಟು ಟೈಮ್, 4 seconds ಆದ್ಮೇಲೆ ಗುಡುಗು ಬಂತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, 4 seconds ಅಂತ ಹಾಕ್ತೀವಿ. ಆಗ ನಮ್ಗೆ ಆಕ್ಚುಲ್ ಎಷ್ಟು ಕಿಲೋಮೀಟರ್ ದೂರದಿಂದ ಈ ಗುಡುಗು ಬರ್ತಿದೆ ಅಂತ ಗೊತ್ತಾಗೋಗುತ್ತೆ. So why I am telling you this is because students or children can calculate so many things today without calculators, without pencil and paper. They can just do this mind calculation immediately with seconds. So that becomes the basis of innovation. You start working with your brain, you start giving exercise to your brain out of common sense. If I ask the same question, I have asked the same question to my students at higher level, whether it is degree friends or my BH students, most of the time they would say, ma'am, how is that possible? How do we calculate distance? Because this is lightning and matter of thunder, and we don't have any formula for that. We don't know any formula. But it is that formula which we have learned in 8th standard, but we are unable to implement that when it comes to real life situation. So this is the problem. And when I told you about we have to count it like 1 1s are 1, 1 2s are 2, 1 3s are 3, 1 4s are 4, like this. It is simply that we are trying to tell one in the span of 1 second. 1 second ಆಗೋ ತನಕ ನಾವು 1 ಅಥವಾ 2 ಅಂತ ಕೌಂಟ್ ಮಾಡಬೇಕು. ಬರೀ 1 2 3 ಹೇಳ್ಬಿಟ್ರೆ ಬೇಗ ಮುಗ್ದೋಗುತ್ತೆ, ಸೆಕೆಂಡ್ಸ್ ಕೌಂಟ್ ಆಗಲ್ಲ. ಅದಕ್ಕೆ 1 1s are 1, 1 2s are 2, 1 3s are 3 ಅಂತ ಹೇಳ್ಕೋಬೇಕಾಗುತ್ತೆ. So these are some basic things which we can tell our students to get to implement some innovative ideas inside their thought process, so that we can make it really effective. We can give them the basic of starting with something new. So going to the next explanation. So I told you about this, applying variables and constants. Now, since speed we didn't know, and time we have just only got through our 1 1s are 1 count, and there is another variable called distance. We didn't know that we would actually apply this. Now, when we realize that, okay, speed of light is a constant, a speed of light ಅನ್ನೋದನ್ನ ಯಾರು ಬದಲಾಯಿಸಕ್ಕಾಗಲ್ಲ ಯಾರು, ಅದರಿಂದ ನಾವ್ ಏನ್ ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳಿದ್ರೆ, ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ನ ನಾವು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ತಗೊಂಡು ಹಾಕೊಳ್ಬಹುದು. ನಾವು there's only one variable to find out, ಡಿಸ್ಟೆನ್ಸ್ ಮಾತ್ರ ಕಂಡುಹಿಡಬೇಕು, 2 ಸಿಕ್ಕಿದೆ, ಅದರಿಂದ ನಾವು ಕಂಡುಹಿಡಬಹುದು. And it's just a mind calculation and you can come up with answer. And innovation also requires some common sense. I mean, a lot of common sense, because when we talk about such things, you might get your answer as some 1096 square kilometer. The answer for that, when you put time as 4 seconds and speed as 3 into 10 power 8, your answer is naturally like 1096 square kilometer. Now, what is this 1096 square kilometer? ಹಾಗಿದ್ರೆ ಗುಡುಗು ಎಲ್ಲಿಂದ ಬರ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಮೈಸೂರು 550 ಅಷ್ಟು ಏರಿಯಾ, ಅಷ್ಟು 550 ಸ್ಕ್ವೇರ್ ಕಿಲೋಮೀಟರ್ ಇದ್ರೆ, ಇಲ್ಲ ಶ್ರೀರಂಗಪಟ್ಟಣದಿಂದನೋ ಆ ಕಡೆ ನಂಜನಗೂಡಿಂದನೋ ಬರ್ತಿರುತ್ತೆ. ಆಬ್ವಿಯಸ್ಲಿ ಅವರಿಗೂ ಇದೇ ಶಬ್ದ ಕೇಳಿಸಿರುತ್ತೆ ಅನ್ನುವಂಥದ್ದು. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ವಿ ಇನ್ಫ್ಯೂಸ್ physics and maths and geography and the societal changes which can commemorate with all these things. So this is wonderful. When we infuse things, we naturally learn a lot and we get into a lot of new ideas. Yeah, coming to a variable with a pattern. Now, we were speaking a lot about X and Y's and B's and A's. Yeah, it is there. Now, whenever I teach or whenever I speak with children about x square formulas, a square plus b square formula or a plus b whole square formula, they would always consider those things as only numbers. And it is again restricted to algebra alone. Even though it is maths, ಎಲ್ಲವೂ ಗಣಿತದಲ್ಲೇ ಬಂದ್ರೂನು algebra ಮಾತ್ರ ಇದು ಅಂತ ಹೇಳಿ ಬರೀ ನಂಬರ್ಸ್ಗಳು ಮಾತ್ರ ಅವ್ರ ತಲೆಯಲ್ಲಿ ಓಡ್ತಿರೋ ಅಂತಂದ್ರೆ ನಾನು I have observed this. So I think you have also observed this. But it is that they are not able to come out of it or relate that particular thing with something which is relevant to the same subject. ಮ್ಯಾಥ್ಸ್ ನಲ್ಲೇ ಇನ್ನೊಂದು ವಿಷಯ ಇದೆ ಜಾಮಿಟ್ರಿ ಅಂತ, ಅದ್ರ ಜೊತೆ ಕೂಡ ರಿಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಎಷ್ಟೋ ಸಲ ನಮಗೆ ಕಷ್ಟ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅದು ರಿಲೇಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಬಹುಶಃ ಆ ಇನ್ಫ್ಯೂಷನ್, ಬೇಸಿಕ್ ಇನ್ಫ್ಯೂಷನ್ ನಮ್ಗೆ ಹೊಸ ಹೊಸ ಐಡಿಯಾಸ್ನ ಕೊಡುತ್ತೆ ಅಂತ ಅನ್ಸುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, there is a square here. If I have a side of this square as x, two sides are x, then the area of the square is naturally x square. So when I write x square in algebra class, they would just consider that as a number. But it is the same thing even in geometry class. It is not a number, but it is a shape. That is the only difference. So x square plus y square ಅಂದ ತಕ್ಷಣ ಮಕ್ಕಳು ವಿಜುವಲೈಸ್ ಮಾಡ್ಕೋತಿಲ್ಲ ಆಲ್ಜಿಬ್ರಾ ಕ್ಲಾಸ್ ನಲ್ಲಿ. ಅದೇ ಜಾಮಿಟ್ರಿಲಿ ಎರಡು ಚಿತ್ರ ಬರೆದಾಗ, ನಾವು ಎರಡು ಸ್ಕ್ವೇರ್ ಚಿತ್ರ ಬರೆದಾಗ, ಓ ಇದೊಂದು ಸ್ಕ್ವೇರ್ ಇದೆ, ಇದೊಂದು ಸ್ಕ್ವೇರ್ ಇದೆ ಅಂತ ಅವ್ರಿಗೆ ಅರ್ಥ ಆಗ್ತಿದೆ. ಈ ತರ ಕಂಬೈನ್ ಮಾಡಿದಾಗ ಬಹುಶಃ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ವೈ ಸ್ಕ್ವೇರ್ ಅಂದಾಗ ನ್ಯಾಚುರಲಿ ಅವ್ರ ತಲೆಯಲ್ಲಿ ಆ ಇಮೇಜ್ ಬಂದ್ರೆ ಬಹುಶಃ ನಾವು ಹೊಸ ತರ ಯೋಚನೆ ಮಾಡೋಕೆ ಒಂದು ಒಳ್ಳೆ ಬುನಾದಿ ಅಂತ ಅನ್ಸುತ್ತೆ. ನೆಕ್ಸ್ಟ್, ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಗಿವ್ಸ್ a direction, or x square is simply equal to a square with side x and area x square. We know this. Next, when I say a square plus b square is equal to c square. Now this is another thing, a common formula which we all know. A square plus b square is equal to c square. How do we visualize this becomes very interesting. Now a square, there is a square with side a, then adding that with a square with side b, so the area of that will be b square. So there are two squares, a square plus b square, and then that is equal to another square which is entirely different again, which is nothing but c square. There is another square with side c. Now if you have heard about this formula, I think you can type it in the chat box. Do you relate this formula with something? Do you remember this formula? Am I audible? There are some people who are saying that I'm not audible. Yes. Okay. So if you can relate this formula, you can type it in the chat box. Yes. Abhilash, Mr. Abhilash is right. So we'll go with that. Before I reveal that to the others, a square plus b square is equal to c square is a very popular formula, which we know it the other way. But when we write it like this, a square plus b square is equal to another square, c square, which I've aligned in a diamond shape. Now this is nothing but our Pythagoras theorem, which we learn only when in the case of right angle triangles. So right angle triangles, we say that one side will be a, the other side will be b, and the hypotenuse, if that is c, we would say a square plus b square is c square. But why don't we imagine the same theorem in this manner? So it is a square, a and b are squares, and c is also square. So when we have such a visualization in the mind of the learner, I think learners themselves can define the whole thing as what is Pythagoras theorem, or what is the area of a right angle triangle, or how do we calculate the hypotenuse of a right angle triangle. Is very simple. It is the square of one side of the triangle plus adding to that sum of two sides of the triangle, a square plus b square, which is equal to the third side, the square or the third side, that becomes c square. So this is a very simple way of visualizing things. So what is very important in maths or science is to visualize how it looks like, or how do we have to imagine this? What is happening when I say a rocket moves in such a speed? How do we visualize that particular thing? When I say Earth is some or Jupiter is some 800 times the Earth, when I say this, how do we visualize that? So that becomes very important to visualize. Now, coming back to another subject of science with the same concept, the variable squares, E is equal to half mv square. Now, how do we visualize this? We will just visualize this as something where something is moving, an object is moving, and it is giving enormous energy. It is we will analyze that energy only if it is hitting something, and then there is a deformation or shape change on something else. So you take a ball and hit on something, like a wall, and the ball rebounds, is there, you, by the rebounding power of that ball or the elastic property of that ball, you know there is some kinetic energy. But can we actually visualize this in the form of the geometric expression that we've learned? Yes, we'll try this. So can it be E is equal to half m, the half of that mass, particular object, whichever it is, half of the mass of that, with a square called V? Is it possible? Actually, yes, we can visualize things like this. So if there is an object and if it is moving in certain speed or velocity, it will definitely have kinetic energy, and it will be something like, when you visualize, it will be half of that particular mass of that particular object and the area which the velocity is acting on. So if the object is moving on like this, the velocity at every point is acting on the complete area of that object. So we say, yes, it is V square. It's a square. It is talking about area. So energy is playing its role completely when the object is moving at every point. At every point, there is the velocity which is acting on the total area of that object. And by the formula, we take the half mass of that particular object. So yes, we can make or visualize geometry out of physics, and that is really very interesting. So coming to formulae or formula, how many formulas in life have we created? There are so many formulas we know. When we say physics formula, formula in chemistry, formula in maths, there are hundreds of formulae we can list. But have we made one in our life? Actually, yes. Now, how many of you are coffee addicts? I don't know. Most of you would be. Some people are so particular about drinking coffee in one particular shop or some brand, they are very particular in drinking. And why is it like that? It's all about formula, don't you think so? It's all about formula. Because one shopkeeper or one person with that particular brand has a formula which he's applying, and that taste cannot be changed by him, and that taste cannot be replicated by others as well. So that's the formula that that person is using. Whatever we make at home, in kitchen, I think we have hundreds of formula. Each one will have their own recipe, their own style of cooking, and that is based on the formula they use in their kitchen. So we encounter a lot of formulas, but we usually write those. If we happen to write it, can we really do that? Will it really work? It definitely works. When you happen to teach somebody, you will give them instructions based on units and variables and other things without even knowing maths and science is actually attached with this. So if we have to find out the formula for a cup of coffee, in fact, every one of us will have our own taste, our own formulas. In general, if I have to say what is the formula for coffee, we have 1G plus 2S plus 1T plus heat becomes coffee. It's an algebraic expression which you get to know in the kitchen. And now if I say 1G, 1G can be a unit if you take the same glass which I've shown in the picture. If not, if you are substituting with some other glass which is at home, that becomes a variable. Obviously, it's a variable. G becomes a variable. And when you say 2 spoons, the spoon size, maybe it's a same tablespoon which we'll be using, but the spoon size will actually vary. The way we take the hump of sugar, or the lump of sugar we take when we take the spoon and dump it the sugar and we take, it varies. So that becomes a variable. If you're taking the same spoon with the same quantity, yes, it becomes a unit. So it's all about algebra in the kitchen. It's all about geometry, science, formulae, everything is in the kitchen. So we can create formulae in whatever experiment we try to experience. Now, it is the same thing in a scientific manner. When I say the formula for caffeine is C8H10N4O2, it simply means that, okay, there are 8 atoms of carbon and 10 atoms of hydrogen and 4 atoms of nitrogen. It goes on. So C8H10N4O2 is as simple as making a coffee like this. So this is how we make ideas innovative and creative in grasping them. So if I just tell to a class that you have to, you have to formulate something out of chemistry, or you have to by heart this equation, it might be really difficult. But when we simplify it, or when we remove the complex version of it, it is as easy as making a cup of coffee. Okay. Next, coming to an infusion of geometry and biology, how this will work. Now, it is incredible to know that our ancestors, the ancient science was all about physics and biology and geometry all together. They didn't study, or they didn't go through these subjects as different ones, but it was all together. Now, based on that, we can see that once we try to infuse things, the estimation towards accuracy will improve, and the spatial intelligence as well. It is research says that children with capabilities of learning all subjects together, not as different subjects, but by integrating every subject, their estimation towards accuracy has improved, and their spatial intelligence as well. So how do we actually see that? So now this is a very famous thing which we teach in class. If not, we can teach this in class, because we are trying to give them set squares when it comes to degrees and angles and trigonometric calculation. But everything happens in the size of the palm. So you have 0 to 90 degrees just by holding your palm like this. And when we even teach shapes at the very basic level for children, we teach about square and rectangle, so many other things. But when you look at the size of the shape of our palm, it is so wonderful to see that it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 sides when you cut the palm like this, and when you look into the palm, it is 11 sides. And you have to tell me what is this 11-sided object are. No, it's a closed figure. It's an object with 11 sides. That's amazing. It has 11 sides, but why is that children, when we say shape, they wouldn't give an example, say finger or palm? They would give the examples of heart. They would give the example of diamond. But it is also true that our body is having a lot of symmetry, and it has amazing geometrical shapes when we look into the structure of how human beings are, how they have evolved. So coming to our body and geometry, I think there were people in ancient days who could calculate the height of hills and mountains, and who could calculate almost everything just with their hands, with their fingers, and the distances as well. So these are some basic things which we have to make children aware of. So 1 inch can be in your finger, 2 inch can be in your thumb, 4 inch can be in your fist. So there are so many calculations that we can do with the available resources. Usually innovations, as soon as we talk about innovations, we would think, okay, we need facilities, we need technology, we need smart boards for innovative teaching. No, I think technology has become a stereotype now. Technology is one of the methods we have to use in the classroom. But what is this innovation then? Innovation simply doesn't mean that we are using videos or slides or PPT. It is about teaching students to think new in whatever is available. Now, when we look into this picture, it is available there, and all the calculations are in our fingers. We can do it. It's not only about the inches. Let me remind you, we can also calculate light years, which is almost equal to 9 trillion kilometers, the distance between stars in the fingers, in our fingers. So it goes something like this. You can calculate degrees, minutes, just by your hands. And then these kind of exposure to children will definitely give some new ideas, novel ideas, when they actually think further. So in their thought process. And there are some old farmer methods even today. Using your thumb, we can calculate the distance of that road and the height of the hill or the mountain, or the inclination, or how the deviation, what deviation this road has taken. Everything is possible just by estimating with a thumb, the length of that thumb or the angles using the thumb. This is also possible. And if we are really aware of this, new ideas or creative ideas are possible with such basics. Now coming to physics and biology, something really interesting which I went through a few years back was, I was teaching levers to children. And then levers simply is about simple machines, where you use these simple machines to make your work easy, as simple as that. And when we talk about levers, seesaw is a very good example for lever. There are different classes in these levers. And one such example for class 1 lever is a scissor or a cutting plier. When I say scissor or a cutting plier, we always see that there is a fixed point called fulcrum. And one point is where you have to put your effort, and the other, put your effort or force. The other part is about the load, which is being given for a scissor or for a cutting plier to do the work. Now, this is something which we learn in physics. And it is an easy thing and most interesting thing. Most of the students would appreciate this because this is an easy, simple machine logic. which is very well understandable. It is easy to understand, that's all. Now, as and when we were talking about many other things, I observed that people were talking about these backaches as well, and I also had got one. Then we realized what is the reason, and that is because we use a lot of system nowadays, and then we use a lot of mobiles, our lifestyles, and the way we sit, the postures we use every day, the postures we tend to get into because of the use of cell phone and laptop. We all have this tendency of having this, backache near this neck, a little below the neck. So why is that happening? What is the problem? See, if you are looking at the system and if you're looking at the phone, it is obvious that you have to have either headache. First thing should be headache, or second thing it is about your eyes. But no, the very first thing where you get pain is at the bottom of your neck. So why is that? Near your shoulders, why is that? It is as simple as the previous image which I showed you. It is about the simple machine and how we deal with this. See, what happens here is the fulcrum is the neck. As in scissors, there's a fixed point. When you look at the scissor, there's a fixed point, and that is like our neck. That is fixed. And where is this load? Is the head. The head is very heavy. Our heads are very heavy, literally not, but it is really heavy. It's a load. And when you have so much of load falling on your neck, it's obvious that the effort in a scissors, if you have a big sheet of paper, thick sheet of paper, the more you have to press, more forces should be applied to cut that paper. And that is very difficult to put your effort there. So that is what your neck is doing. It is just like your simple machine. So body is a simple machine. It's like your seesaw. The first end of that seesaw, we have our head with the load, and the fulcrum, the fixed point, is the neck, and the back will be the effort point. Obviously, we get pain there. Now, how do we relate this with biology? Is as simple as this one. Now, who said doctors don't need something about physics, or who said biology is nowhere connected with physics? The whole human body is a machine. We're using it as a machine. So yes, there is an infusion, and we have to think outside the textbook, and this is how it works. So if we have to connect in general, another good idea to keep our students engaged or to keep them active is to use these cognitive maps. So using concept maps, whatever we speak or whatever is being explained, they can actually plan it in a short form or a diagrammatic manner where it is just a symbol of how it should be done. So levers, I was talking about levers. It has two things. It can be seen in machines and as well as in human body. If I say it is about simple machines, we see the examples of seesaw, scissors, and many things. And if it is human body, yes, it is the head and the backache which we get, the fingers, when we hold something in our fingers, how the dynamics of these fingers will also teach us the same logic about levers and how the machines will. Okay, next, physics and chemistry. Now, if we have to link physics and chemistry, how often are we trying to link physics and chemistry? It usually happens that when we go and ask teachers of chemistry about any physics thing, see, I'm a chemistry teacher, you please go and ask physics teacher. This is the common reply we give. And we ask somebody of physics, that teacher would say, see, I'm a physics teacher, I don't have chemistry. Or maths, you go and ask the maths teacher. So I think this is something which we should not be doing, because as science and maths teachers, we have to relate the answer when we give it to the children, because they have a general question based on everything they have learned in class. So coming to this one, now it is always wonderful to see how these scientists, whether it is Tycho Brahe or Copernicus or Kepler, they have given the structure of solar system. Solar system, as I was telling you, it's really huge. Nobody can go out in space and see the whole solar system at once. Never. It is not possible at all, because we are all the tiniest thing when it compared to when we compare that with solar system. And the same thing with atoms. Nobody has seen what is the structure of atom. It is just the imaginary thing that they have told us about, and it is the most tiniest thing that we cannot see with our naked eyes. So these two things, they are similar. Though nobody has seen them, scientists from generations, they have come to a conclusion that these two things look very much similar. Solar system also has something like sun, which is holding all the other things binded. And atoms also has something called nucleus, which is holding all the electrons revolving around them, binded like this. So where do we get this knowledge from when nobody is able to see? How is that scientists could compare these two, or scientists could imagine something which is going circular, though they couldn't see it? So that is a novel idea. This is definitely an example, a very good example of innovation, how we have visualized things, how it could have been or how it is. So after generations, it has been changed. Now, when we studied in school, solar system had all 9 planets, and we considered all 9 as planets. But today we say Pluto has its own orbit. It is nowhere connected with the planets. We have only 8 planets. The whole answer has changed now. But in future, we don't know. It can be like this. Maybe the sun will have all the planets like the electrons going around at the nucleus. We don't know. It can change. There can be a prediction like this. So where do we get this idea from? It is due to comparison. It's not about logic. It's not about formulating. It's also important to compare things of what has happened in the history, of what has happened in something which we cannot visualize at all. Is there any proof of visualizing such things? Or what is it actually giving? What can be the structure? Imagination. Imagination plays a very important role before you get into some creative or new ideas. So innovation and science are pretty easy now, because we are trying to relate many things, infuse all the subjects together, and then try to give the result, or try to infer what it could be. So innovation is an easier thing now. The scope for innovation will be more. And let me also tell you that children learn very easily with stories. Most of the learners will find learning easy through stories. You tell them a story, and that is it. They will understand it like they can never forget it again. So not definitions, not formulae, not mnemonics. Apart from all these things, stories are the best friends for children to learn. So if that is the case, let me share a video with you. Please observe that video. Here, we are talking about properties of oxygen. If you have already watched this video, well and good, but you can watch it again. So properties of oxygen, instead of listing them in a science class, we are trying to put it as a story. So what happens for oxygen and what are the properties of it? Let us watch it. So oxygen, when it goes with helium, what happens?
Oxygen has discovered 50% of them, and they now be seen playing with barium. But they should be careful playing in that rocket, since oxygen is often used as ignition energy. Enough barium is also used in fire, which produces a brilliant green fuel. Hydrogen, young friend. Nothing bad will happen. That is, unless a special one does. That's it for oxygen. Be sure to watch our next lesson where we investigate the effects of helium in the upper atmosphere.
Okay, so that's for oxygen and how oxygen would react with different elements in the periodic table and what are the properties of oxygen. And this is how we put it in the form of a story. So when it is stories and scripting a scene in science, there are two things actually happening. One is a concept in science can be from a story, or a story can be from a concept of science. Now, whatever you see, whatever you saw in the video, it was about oxygen, and we already have a science out there, and we are trying to construct a story. So the science, the properties of science are scripted in the form of a character, and then it is played, it is written in the form of a story, and then it is played either in the form of animation or a drama or anything else, or a short film, whatever. But there is another method which is really interesting, where you take science from a story. There is already a story which we all know, very popular story. This story, I think, there isn't anybody who don't know the story. Hare and the Tortoise, we all know the story. Then if we have to teach science from this story, what would we teach is very simple, that we find a lot of scientific concepts here, and then we understand, okay, the story is nothing but science. So when we start with the story, we know that there'll be a race between hare and the tortoise, and then tortoise will start walking, hare will start running. And then after some time, hare thinks that, okay, tortoise is very slow, I want to stay, I want to stop there. And then afterwards, tortoise, it realizes that tortoise kept on moving with the same velocity. So we have velocity there. And when we talk about velocity of the tortoise, it is nothing but uniform velocity, where it is not at all changing. Then we talk about velocity of the rabbit or the hare. See, it is changing. When velocity changes, we call it acceleration, as simple as that. So the rabbit or the hare is accelerating there, and it is coming to the final position or the resting position in between. Again, it has another initial velocity. So, but when it comes to tortoise, it has constant velocity or uniform velocity throughout the race, and it will win the race. So we have so many things here. Apart from velocity, we also talk about distance, displacement, speed, and many, many things. So this is how we frame a scene. We formulate a scene out of existing story. So there is science in a story which is already there. And when you look into the story of that oxygen, we have science, and we are converting that science or the set of properties of science into a story. So this is one very interesting thing that we have done in our classes, and that has really worked out really well. You can try this as well. So this is one innovative method. So here I would remind you once again that, see, innovative method is not about just using technology. It's not about using a new device. It's not about showing something which is ready-made. It is also about making them think and giving some work for students and for ourselves. We have to have some work where we can manipulate and find out, okay, if this can suit something, or if this has a solution. So another example I would give is from this slide. So stories and scripting is seen from science. Again, we are going back to a story which can be from science. We are deriving that from science. So here, this image, whenever I see students with this image in that, either in the textbook or in their PPT or wherever it is, they hesitate to start learning this thing. As soon as they look into it, it is very complicated for them. They look into the waves. Okay, waves are complicated. There is difference in wave, and there are so many numbers here which talks about 0.00. First constant number itself is like very difficult for them, and when they see the decimal points, they'll hesitate to start even studying anything out there. So 0.0001 nanometer, okay, what is it? It's again difficult thing. When we talk about gamma rays, X-rays, ultraviolet rays, just slide like this. Though it is a slide, it is colorful, it is so legible. Children wouldn't want to start studying this. Now, how do we make it really simple and understandable? Is we put images like this. So that is one innovative idea of putting images, adding images, and make them recall what are the lens or what is the wave about as soon as they look into images. It's very easy now. So as soon as they see wavelength about 10 power 8, it's about the network tower. They'll recall that network tower, and you're using mobile. They are using. They have noticed what is this X-ray and how is it taking place. They know what is TV. They know how these a bulb works. What is this rainbow color? Where have they seen a rainbow? They know this. So it is easy for them to visualize things. So this is what in my first slide I was trying to tell you. So innovation includes infusion as well as visualization. So next it is important for them to actually understand the details of it. Now they can identify what is a wave and where these waves are applicable, but how good are they in actually recalling or remembering the numbers or the values which is related with these waves? So when we teach this, we can simplify this. The whole PPT ಏನಿದೆ ಅದನ್ನ ಇನ್ನೂ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಕತೆ ತರ ಹೇಳೋದಾದ್ರೆ, ರೇಡಿಯೋ ವೇವ್ಸ್, ಮೈಕ್ರೋವೇವ್ಸ್, ಇನ್ಫ್ರಾರೆಡ್ ರೇಸ್ ಅಂತ ಹೇಳೋಕ್ಕಿಂತ ನಾವು ಅವ್ರು ಹೇಳ್ಕೊಡ್ತೀವಿ ಒಂದ್ ಕತೆ. ಒಂದ್ ಊರಲ್ಲಿ ಒಬ್ಬ ಅಜ್ಜ ಇದ್ದ, ಅವನಿಗೆ ಎಷ್ಟು ಜನ ಮಕ್ಕಳು ಅಂತ ಹೇಳುವಾಗ 1 2 3 4 5 6 ಜನ ಮಕ್ಕಳು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. 7 ಜನ ಮಕ್ಕಳು. 7 ಜನ ಮಕ್ಕಳು ಯಾರ್ಯಾರು ಅಂತ ಹೇಳುವಾಗ ಮೊದಲನೇವಳು 7 ಜನ ಹೆಣ್ಮಕ್ಳನ್ನ ಮೊದಲನೇವಳು ಯಾರು? ರಾಜಕ್ಕ ಅಂದ್ರೆ ರೇಡಿಯೋ ವೇವ್ಸ್. ದೇ ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ಲೈಕ್ ದಿಸ್. ಈ ರಾಜಕ್ಕ ಎಷ್ಟು ದೊಡ್ಡದಾಗಿದ್ಲು ಅಂತ ಹೇಳಿದ್ರೆ ಚಾಮುಂಡಿ ಬೆಟ್ಟಕ್ಕಿಂತ ಎತ್ತರವಾಗಿದ್ಲು ಅಂತ ಹೇಳುವಾಗ now they understand the size of that wave. One wave is higher than Chamundi Hills. So radio wave is very long. 10 power 8 is simply very high. 10 power 5, 4, 10 power 3, 10 power 2. We go like this. So ರಾಜಕ್ಕ ಅಂದ್ರೆ ತುಂಬಾ ದೊಡ್ಡದಾಗಿರ್ತಾಳೆ ನೋಡಕ್ಕೆ ಅಂತ ಹೇಳುವಾಗ ಅವ್ರಿಗೆ ಇಮ್ಯಾಜಿನೇಷನ್, ರಾಜಕ್ಕ ಫಸ್ಟ್ ಮೊದಲನೇ ಮಗಳು. ಸೊ ಇನ್ ದ ವೇವ್ ಲೆಂತ್ ಆರ್ಡರ್ ಇಟ್ ಇಸ್ ಫಸ್ಟ್ ರೇಡಿಯೋ ವೇವ್ಸ್, ದೆನ್ ಮಂಜಕ್ಕ ಅಂತ ಕೊಡ್ತೀರಿ ಮೈಕ್ರೋವೇವ್ಸ್. ಮಂಜಕ್ಕ ಚಿಕ್ಕೋಳು, ಕಿರಿಯೋಳು, ಅವಳನ್ನ ಕೈಯಲ್ಲಿ ಹಿಂಗೆ ಎತ್ಕೋಬಹುದಂತೆ, ಅವಳನ್ನ ಅಷ್ಟು ಚಿಕ್ಕೋಳು ಅಂತ ಹೇಳಿದಾಗ ದೇ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಓಕೆ ದೀಸ್ ಮೈಕ್ರೋವೇವ್ಸ್ ಆರ್ ರಿಯಲಿ ಮೈಕ್ರೋ ಇನ್ ನೇಚರ್. ಆಮೇಲೆ ಬರೋದು ಇಂದ್ರಕ್ಕ, ಇನ್ಫ್ರಾರೆಡ್ ರೇಸ್ ನ ಇಂದ್ರಕ್ಕ ಅಂತ ಹೇಳ್ಕೊಡ್ತೀರಾ. ಆಮೇಲೆ ಉತ್ತರಕ್ಕ ಅಂತ ಹೇಳ್ಕೊಡ್ತೀರಿ, ಅಲ್ಟ್ರಾ ವೇವ್ಸ್, ಅವ್ರಿಗೆ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋಕೆ ಸುಲಭ ಆಗ್ಲಿ ಅಂತ. ಇಟ್ ಇಸ್ ಕ್ವೈಟ್ ರೀಜನಲ್ ನಾವು, ಯು ಕ್ಯಾನ್ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಥಿಂಗ್ಸ್ ಇನ್ ಟು ರೀಜನಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅಂಡ್ ದ ಸ್ಟೋರೀಸ್. ಎಕ್ಸ್ ರೇಸ್ ಸೀತಕ್ಕ ಅಂತ ಹೇಳ್ಕೊಡ್ತೀರಿ, ಆಮೇಲೆ ಗಾಮಾ ರೇಸ್ ಗೀತಕ್ಕ ಅಂತ ಹೇಳ್ಕೊಡ್ತೀರಿ. ಈಗ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಅಂತ ಒಬ್ಬ ಅಜ್ಜ ಇದ್ದ, ಅವನಿಗೆ ಎಷ್ಟು ಜನ ಮಕ್ಕಳು ಅಂತ ಹೇಳಿದ್ರೆ ಸರಾಗ ಮಕ್ಕಳು ಹೇಳ್ಕೊಂಡ್ ಬರ್ತಾರೆ. ಆರ್ಡರ್ ಹೇಳಿ ಅಂದ್ರೆ ರಾಜಕ್ಕ, ಮಂಜಕ್ಕ, ಇಂದ್ರಕ್ಕ, ಉತ್ತರಕ್ಕ, ಸೀತಕ್ಕ, ಗೀತಕ್ಕ ಅಂತ ಹೇಳ್ಬಿಡ್ಬೋದು. ಸೊ order is there, you have visible light there, you know the length of the visible light, you know how you can visualize how big a wave is when you give such examples. ಇನ್ನು ನೆಕ್ಸ್ಟ್ ಲೆವೆಲ್ಗೆ ಹೋಗೋದಾದ್ರೆ, ಒಂದು ಸ್ಕ್ರಿಪ್ಟಿಂಗ್ ಅಂತ ಕರೆಯುವಾಗ, ಒಂದು ಕಥೆನೇ ಬರೀಬೇಕು ಅಂತ ಅನ್ನುವಾಗ, ಈ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಅನ್ನೋ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನ ನಮ್ಮ ಮಕ್ಕಳು ಇಲ್ಲಿ ಒಂದು ನಾಟಕವಾಗಿ ಮಾಡಿದ್ದಾರೆ. ಅದನ್ನ ನಾನು ಐ ವುಡ್ ಲೈಕ್ ಟು ಶೇರ್ that with you, and that has become the most effective way of learning. So we call it participative learning. ಪ್ರತಿಯೊಬ್ರು ಬರೀ ಕಲ್ತ್ಕೊಳ್ಳೋದಲ್ಲ, ಅದರಲ್ಲಿ ಭಾಗಿಯಾಗಿ ಪರ್ಫಾರ್ಮ್ ಮಾಡಿ ಅನಂತರ ಅದನ್ನ ಕಲ್ತ್ಕೊಳ್ಳೋದನ್ನ ನಾವು ನೋಡ್ತೀವಿ. ಐ ವುಡ್ ಲೈಕ್ ಟು ಶೇರ್ that now with you. So yeah, maybe not complete drama, but I'll just try to share some glimpses of what we have done. It is the theatric version of science, pedagogy dramas. I would like to summarize on the drama what is happening. Electromagnetic wave ಅನ್ನೋದು ಯಮಂಗ್ ಹೋಲಿಸಿದ್ದಾರೆ. 7 ದೇವತೆಗಳನ್ನ 7 ವೇವ್ಸ್ ಅವ್ರಿಗೆ ಹೋಲಿಸಿ ಅವ್ರನ್ನ ಯಮ ಕೇಳ್ತಾನೆ, ನನಗಿಂತ ಶಕ್ತಿಶಾಲಿ ಯಾರು ಭೂಲೋಕದಲ್ಲಿ ಅಂದಾಗ ಈ 7 ಜನ ಬರ್ತಾರೆ, ಬಂದು ನಿಂತ್ಕೊಳ್ತಾರೆ. ಇದೆಲ್ಲ ರೀಜನಲ್ ಆಗಿರೋದು. ನಾರದ್ರು ಬಂದು ಹೇಳ್ತಾರೆ, ಈ 7 ಜನನೇ ನಿಮ್ಗಿಂತ ಬಲಶಾಲಿ ಅಂತ. ಆಗ ಅವ್ನು ಹೇಳ್ತಾನೆ, ಕರ್ಸಿ ಎಲ್ಲಾರ್ನು ಅಂತ ಹೇಳ್ತಾನೆ. Okay, this is just a glimpse of what we've done as an experiment of putting science into theater, and that has really turned out very well. I'm sorry. Okay, so scripting a scene from science is one interesting and most innovative method which I have encountered. I think you also would have a lot of ideas like this. So if you have, please do share with me. And then this is about cognitive maps, how these things will work on the screen and on the papers, like when you give them, when you share such cognitive maps with your students, how will they try to analyze? And not much about this, but I would like to tell you, we've done an experiment for 4 groups of students where one was with cognitive maps, the other was without cognitive maps, and then they were evaluated for a score of 20. Then we understood that yes, cognitive map is an innovative method of understanding things or making learning easy when it comes to science and maths. So the blue color you're seeing is only the theory class, when it is the red color bar graph which you're seeing is through cognitive maps. With theory, how cognitive maps will support them to learn how we can make learning easy and effective. So some more cognitive maps, if you want to try, there are some websites which I've given here. We have almanac.com, Visme, Lucidchart, Golnaba, VUE. That's a software that you can download for free and then do it, where you can attach images as well. And VUE is one such software where you can also ask them to do the evaluation. So if you have any fill in the blanks, they can do it. And you have app.mindmap and so many things where you can use these things for your class and cognitive maps. Finally, if you have any method which you think is innovative, how do you analyze that? So we'll do a fast SWOT analysis where we talk about strength of it. Is it really advantageous for teachers and learners? Is it reaching many learners? Is it really simple, effective, and easy to communicate? So that becomes, yes, your new idea can be innovative. And we have to talk about, we have to analyze about the weakness of it, where is it really time consuming, or is it very expensive, or is it really relevant to the context that we are speaking? And then coming to opportunities, is it available to everybody? Is it democratic? Is it relevant? Is it age appropriate to the class which we are teaching? And it's also about the threats which we should be aware of. Is it really distracting? Now, for example, drama is a very interesting and effective way of teaching science. But sometimes it is also true that it is very distracting. You might learn only that dialogue. For example, if you are a microwave, if you have the role of microwave, you will be very well versed in learning that things, and there are chances that you end up with not focusing much about science, but about many other things when it is a group activity. So is it really misleading? You cannot script something. Though it is from science, scripting is really a hard job, because we cannot just we cannot write whatever we want just because we are making into a drama or a story. We have to have all the scientific components without neglecting them, or without disturbing that focus of the concept. We have to write a script. So that is a really hard task. And the last one is evaluation. So how good it is when you have to find out if they've really understood, or was it really effective. So these are some SWOT analysis concepts if you also have some innovative ideas with you. So if you have any questions now, you can ask me. If you don't have it now, or if you have it later, you can just mail me in this email address. If you have any questions, you can ask me. Okay, I think there isn't any questions. If there's any questions on the YouTube chat box, you can ask me. Okay, so innovation method is itself something which will strike you immediately, not immediately after my presentation, or somewhere when you're doing something really serious, there you have that innovative idea. So that immediate thought itself is innovative. If that way, if you have anything, you can just ping me with my mail ID, which I've given there, and you can just follow with the references which I've shown. So thank you, everyone. Yes, yes.
Ma'am?
Yes, Pooja?
Ma'am, Vishwas sir is asking some question in the chat box, ma'am.
Okay, okay. Vishwas Jason sir. Okay, sir is asking that most of my students have a notion that physics is tough. It's because at a high school level, it's infused with maths. Yes, most of them involving exponents. How do I convince them that it's not as hard as they think? Okay, so let me tell you, when it is about exponents, as I told you, especially with the lessons involving light and electricity, I know. We have done this experiment, sir. When it comes to calculation, yes, exponential calculation requires some basics to start with. As I told you, see, I can't start something because I have to make algebra simple. I can't start simply like that. I have to tell them where these algebra starts from and what is it actually referring to. So exponents is also one beautiful concept where where it is important that we teach them visualization again. Now, when I say x square, x times x, how should it look like? I think that visualization is more important. Now, when I say x power 3, x cube, how should it look like? Suddenly, the idea of cube should not be just on the paper or a 2D, it should become a cube when they imagine. So that kind of a visualization of, if you have any animation that can help you visualize such things, then that will certainly help you, sir, with the exponential form. And how huge it can be, how multiplied it is, or how complicated it is. For example, you're talking about a Rubik's cube. Now, if Rubik's cube had to have a formula, how do you write a formula? Such basic exercises would help, I think, sir. So you can try that, Vishwas, sir. And coming to electricity chapter and light chapter, yes, our students have also taken up this as their pedagogy drama, where we'll talk about circuits. See, children always have problem with this series, parallel connection, what is a resistor, what is a capacitor, what is this Ohm's law. They always have a problem, but we have tried putting that into theater. We have also had a drama which is about electricity, where resistor is like a bodyguard ಫಾರ್ ವಿಲೇಜ್. ಊರದ್ದು ದೊಣ್ಣೆ ನಾಯಕ ಅಂತ ಹೇಳ್ತಾರಲ್ಲ, ಅದು ರೆಜಿಸ್ಟರ್ ಆಗಿರುತ್ತೆ. ಒಂದು ವೈರ್, ಒಂದು ವೆಹಿಕಲ್ ತರ ಮಾಡ್ಕೊಂಡು ಆ ವೈರ್ ಮೇಲೆ ಕರೆಂಟ್ ಟ್ರಾವೆಲ್ ಮಾಡ್ಕೊಂಡು ಬರುತ್ತೆ. ಹಿಂಗೆ ಕತೆ ಹೆಣಿಯೋದ್ರ ಮೂಲಕ ನಾವು ಹೇಳ್ಕೊಟ್ಟಾಗ ಬಹುಶಃ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಅನ್ನೋದು ತುಂಬಾ ಸಿಂಪಲ್ ಅಂತ ಅನ್ಸುತ್ತೆ. ಸರ್ಕ್ಯೂಟ್ ಎಲ್ಲ ನಾವೇ ಓನ್ ಆಗಿ ಮಾಡ್ಕೊಂಡು ಅದ್ರ ಫಾರ್ಮುಲಾ ಬರಿಬಹುದು ಅಂತ ನನಗನ್ಸುತ್ತೆ. ಓಕೆ, ಎನಿ ಅದರ್ ಕ್ವೆಶನ್ಸ್? ಇಫ್ ಯು ಹ್ಯಾವ್ ಎನಿ ಅದರ್ ಕ್ವೆಶನ್ಸ್ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಮೀ. ಐ ಹೋಪ್ ನಾಟ್. ಓಕೆ, ಸೊ ನಿಮಗೆ ಇನ್ನೋವೇಷನ್ ಅನ್ನೋದು ಯಾವಾಗ ಹೊಳೆಯುತ್ತೆ ಅವಾಗ ಸಡನ್ ಆಗಿ ಏನಾದರೂ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು ಅಂತ ಅನ್ಸಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಮೇಲ್ ಮೀ ಅಂಡ್ ಐ ವಿಲ್ ಬಿ ರೆಡಿ. ಐ ವಿಲ್ ಬಿ ವೆರಿ ಹ್ಯಾಪಿ ಟು ಡಿಸ್ಕಸ್ such new ideas with you. We can sit together, sort it out, and then find out how we can implement such innovative ideas. Thank you very much.
ತಮ್ಮಲ್ಲಿರುವ ನವೀನ ಪರಿಕಲ್ಪನೆಗಳನ್ನು, ನವೀನ ಬೋಧನಾ ಶೈಲಿಗಳನ್ನು, ಒಂದು ವಿಷಯವನ್ನು ಹೇಗೆ ವಿಭಿನ್ನ ಆಯಾಮಗಳಿಂದ ನೋಡಿ ಅರ್ಥೈಸಿಕೊಳ್ಳಬೇಕೆಂದು ತಮ್ಮ ವಿಚಾರಧಾರೆಯನ್ನು ನಮ್ಮೆಲ್ಲರೊಂದಿಗೂ ಹಂಚಿಕೊಂಡಂತಹ ಶ್ರೀಮತಿ ಶಾಲೋಮ್ ಸನ್ನತಾ ಮೇಡಮ್ ರವರಿಗೆ ವಂದನೆಗಳು. ಇದೀಗ ನಾವು ಕಾರ್ಯಕ್ರಮದ ಅಂತಿಮ ಘಟ್ಟಕ್ಕೆ ಬಂದು ತಲುಪಿದ್ದೇವೆ, ಅದುವೇ ವಂದನಾರ್ಪಣೆ. ನಮ್ಮ ಕಾಲೇಜಿನ ದ್ವಿತೀಯ ವರ್ಷದ ಪ್ರಶಿಕ್ಷಣಾರ್ಥಿಯಾದಂತಹ ಕುಮಾರಿ ನಂದಿನಿರವರನ್ನು ವಂದನಾರ್ಪಣೆಯನ್ನು ನೆರವೇರಿಸಿಕೊಡಬೇಕೆಂದು ವಿನಂತಿಸಿಕೊಳ್ಳುತ್ತೇನೆ.
ಎಲ್ಲರಿಗೂ ಮಧ್ಯಾಹ್ನದ ಶುಭಕಾಮನೆಗಳು. ಮೊದಲಿಗೆ ಇಂದಿನ ಗಣಿತ ಮತ್ತು ವಿಜ್ಞಾನ ವಿಷಯವನ್ನು ನವೀನ ರೀತಿಯಲ್ಲಿ ಬೋಧಿಸುವುದನ್ನು ತಿಳಿಸಿಕೊಟ್ಟಂತಹ ನಮ್ಮ ಕಾಲೇಜಿನ ಭೌತಶಾಸ್ತ್ರ ಉಪನ್ಯಾಸಕರು ಮತ್ತು ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಯಾದ ಶ್ರೀಮತಿ ಶಾಲೋಮ್ ಸನ್ನೂತಾ ಮೇಡಮ್ ರವರಿಗೆ ತುಂಬು ಹೃದಯದ ಧನ್ಯವಾದಗಳು. ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಪಾಲ್ಗೊಂಡ ಪೂಜ್ಯ ವಂದನೀಯ ಗುರುಗಳಾದ ಫಾದರ್ ವಿಜಯ್ ಕುಮಾರ್ ರವರಿಗೂ ಹೃತ್ಪೂರ್ವಕ ಧನ್ಯವಾದಗಳು. MDES ನ ಆಡಳಿತಾಧಿಕಾರಿಯಾದಂತಹ ಫಾದರ್ ಅವಿನಾಶ್ ಸರ್ ಅವರಿಗೂ ಹೃತ್ಪೂರ್ವಕ ಧನ್ಯವಾದಗಳು. MDES ನ ತರಬೇತಿ ಮತ್ತು ಅಭಿವೃದ್ಧಿಯ ಕಾರ್ಯನಿರ್ವಾಹಕ ಅಧಿಕಾರಿಯಾದಂತಹ ಶ್ರೀಯುತ ಸೆಬಿ ಮಾವೇಲಿ ಅವರಿಗೂ ಕೂಡ ಹೃದಯಪೂರ್ವಕ ಧನ್ಯವಾದಗಳನ್ನು ಕೋರುತ್ತೇನೆ. ಸಂತ ಜೋಸೆಫರ ಶಿಕ್ಷಣ ಮಹಾವಿದ್ಯಾಲಯದ ಪ್ರಾಂಶುಪಾಲರಾದ ಶ್ರೀಮತಿ ಡಾಕ್ಟರ್ ಪ್ರಿಯಾ ಮ್ಯಾಥ್ಯೂ ಮೇಡಮ್ ರವರಿಗೂ ಮನಪೂರ್ವಕ ಧನ್ಯವಾದಗಳನ್ನು ಕೋರುತ್ತೇನೆ. ಪ್ರಾರ್ಥನೆ ನಡೆಸಿಕೊಟ್ಟಂತಹ ಸಿಸ್ಟರ್ ರೀನಾ ಮತ್ತು ತಂಡದವರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು. ಹಾಗೂ ತಾಂತ್ರಿಕ ತಂಡದಲ್ಲಿ ಉತ್ತಮ ಸಹಕಾರ ನೀಡಿದ ಚೆಲುವರಾಜ ಸರ್ ಮತ್ತು ರಕ್ಷಿತ್ ಸರ್ ಅವರಿಗೂ ಧನ್ಯವಾದಗಳು. ಕೊನೆಯದಾಗಿ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಭಾಗವಹಿಸಿದ ಎಲ್ಲಾ ಶಿಕ್ಷಕರಿಗೂ ಮತ್ತು ಪ್ರಶಿಕ್ಷಣಾರ್ಥಿಗಳಿಗೂ ಮನಪೂರ್ವಕವಾಗಿ ಧನ್ಯವಾದಗಳನ್ನು ಕೋರುತ್ತೇನೆ. ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಪ್ರತಿಯೊಬ್ಬರಿಗೂ ಧನ್ಯವಾದವನ್ನು ಅರ್ಪಿಸಲು ಅವಕಾಶ ಮಾಡಿಕೊಟ್ಟಂತಹ ಎಲ್ಲರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು.
ಧನ್ಯವಾದಗಳು ನಂದಿನಿ. ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಪಾಲ್ಗೊಂಡಂತಹ ಸರ್ವರಿಗೂ ವಂದನೆಗಳನ್ನು ಅರ್ಪಿಸುತ್ತೇನೆ.
ಧನ್ಯವಾದಗಳು ಪೂಜಾ ಮತ್ತು ನಂದಿನಿ. ಇದುವರೆಗೂ ನಿಮ್ಮ ಮುಂದೆ ಗಣಿತ ಮತ್ತು ವಿಜ್ಞಾನ ಬೋಧನೆಯಲ್ಲಿ ನಾವೀನ್ಯಯುತ ಅಭ್ಯಾಸಗಳು ಎಂಬ ವಿಷಯವನ್ನು ಯಶಸ್ವಿಯಾಗಿ ಪ್ರಸ್ತುತಪಡಿಸಿದ ಸಹೋದ್ಯೋಗಿ ಮಿತ್ರರಾದ ಶ್ರೀಮತಿ ಶಾಲೋಮ್ ಸನುತಾ ಮೇಡಮ್ ರವರಿಗೆ ಧನ್ಯವಾದಗಳನ್ನ ಅರ್ಪಿಸುತ್ತಾ ಅವರ ಒಂದು ಕಿರು ಪರಿಚಯವನ್ನ ನಿಮ್ಮ ಮುಂದಿಡಲು ಹರ್ಷಿಸುತ್ತೇನೆ. ಇವರು ಭೌತಶಾಸ್ತ್ರ ಮತ್ತು ಶಿಕ್ಷಣ ಶಾಸ್ತ್ರದಲ್ಲಿ ಸ್ನಾತಕೋತ್ತರ ಪದವಿಯನ್ನ ಮೈಸೂರಿನ ಮಾನಸ ಗಂಗೋತ್ರಿಯಲ್ಲಿ ಪಡೆದಿದ್ದು, ಶಿಕ್ಷಣದಲ್ಲಿ ನೆಟ್ ಮತ್ತು ಕೆಸೆಟ್ಗಳನ್ನು ಪಡೆದು ಅರ್ಹತೆ ಗಳಿಸಿರುತ್ತಾರೆ. ಇವರು ಸಂತ ಫಿಲೋಮಿನಾ PU ಕಾಲೇಜಿನಲ್ಲಿ, ಮೌಲಾನಾ ಆಜಾದ್ BEd ಕಾಲೇಜಿನಲ್ಲಿ ಸೇವೆ ಸಲ್ಲಿಸಿದ್ದು, ಶ್ರೀಯುತರು 2017ರ ಮಾರ್ಚ್ನಿಂದ ನಮ್ಮ ಸಂಸ್ಥೆಯಲ್ಲಿ ಕಾರ್ಯನಿರ್ವಹಿಸುತ್ತಿದ್ದಾರೆ. ಬೋಧನೆಯಷ್ಟೇ ಅಲ್ಲದೆ ಪ್ರವೃತ್ತಿಯಲ್ಲಿ ಹಾಡುಗಾರರಾಗಿರುವ ಇವರು ನಾವು ಎಂಬ ತಂಡದಲ್ಲಿ ಸಕ್ರಿಯರಾಗಿದ್ದಾರೆ. ಬಹುಮುಖ ಪ್ರತಿಭೆಯಾಗಿರುವ ಇವರು ನಾಟಕ ಮತ್ತು ಕಲೆಯನ್ನ ಬೋಧನೆಯಲ್ಲಿ ಅಳವಡಿಸುವುದರ ಕುರಿತು ಪ್ರಶಿಕ್ಷಣಾರ್ಥಿಗಳಿಗೆ ಆ ಕೌಶಲವನ್ನ ಬೆಳೆಸ್ತಾ ಇದ್ದಾರೆ. ಧನ್ಯವಾದಗಳು. ಅವರ ಪರಿಚಯವನ್ನ ಮುಂದಿಡೋದಕ್ಕೆ ತುಂಬಾನೇ ಖುಷಿ ಅನ್ನಿಸ್ತಿದೆ. ಇಂದಿಗೆ ಇವತ್ತಿನ ನಮ್ಮ ಕಾರ್ಯಕ್ರಮವು ಮುಗಿದಿದ್ದು, ನಿಮಗೆ ನಿಮ್ಮ ಇಮೇಲ್ನಲ್ಲಿ ನಾವು ಫೀಡ್ಬ್ಯಾಕ್ ಫಾರ್ಮ್ ಅನ್ನ ಕಳಿಸ್ತೀವಿ. ನೀವು ಅರ್ಧ ಗಂಟೆಯ ಒಳಗೆ ನಮಗೆ ನಿಮ್ಮ ಫೀಡ್ಬ್ಯಾಕ್ ಅನ್ನ ತಲುಪಿಸ್ಬೇಕು. ನಿಮ್ಮ ಫೀಡ್ಬ್ಯಾಕ್ ಫಾರ್ಮ್ ನಿಂದ ನಾವು ನಿಮ್ಮ ಹಾಜರಿಯನ್ನ ತೆಗೆದುಕೊಳ್ಳುತ್ತೇವೆ. ಧನ್ಯವಾದಗಳು. ಭೇಟಿಯಾಗೋಣ.